Alright, we're back on track now. I figured out what was going wrong, and I've had a nightmare of a 30 hours or so. 30 hours? Yeah, about 30 hours. What was being shown on stream wasn't at all sensitive, so feel free to go look at it in the Twitch VODs and laugh at what it was. It was just my pre-stream test. But what happened yesterday was I was due a reboot to pick up a new kernel. And I thought, oh yeah, it's a reboot, what could go wrong? And you think, well, new kernel can certainly go wrong. And the universe decided to toss a real spanner in that works and kill a disk on reboot. Like, on reboot, System D had a dependency failure because one of my two disks was just kicking out read errors going, nope, you're not mounting me, nope, you're not talking to me. So yeah, it was working fine during the day. I rebooted, and as of then, no more disk talkie. I even went and took it and plugged it into a desktop machine and was getting the exact same read errors. So I got to spend yesterday and last night rebuilding my machine because I've got two disks, and like the idiot I am, I run off an SSD. But I was running out of room on that SSD because I set up my partitions weirdly, and I've learnt my lesson. I've just got flat partitioning now. And what I was doing was, as my root file system grew and grew, I would just take bits of it and go, okay, you can live on the hard drive, and I'll symlink from the SSD to the hard drive, and all the bulk data can live on the hard drive. So then when the hard drive dies, your machine doesn't want to boot, which is not good. So I had to do a backup of what was on the SSD, wipe it, repartition, because I had been meaning to repartition anyway and reinstall anyway. I needed to do it, but I didn't expect to do it on a work day, the day before a stream I was very much looking forward to. So that happened, and then I got everything set back up, and now I'm hitting a VirtualBox bug, which what happens is it's interacting poorly with i3 right now, and I've looked into the issue trackers, and they're not exactly sure within which cam's going to turn my music down a bit. They're not exactly too sure. Oops, no. Let's do that. Hello? Alright, let's do that. The developers aren't too sure which camp the problem lies in, whether it's a bug in i3 or whether it's a bug in VirtualBox. But what it means is if you pop VirtualBox, like from the get-go, you boot a box up and the graphics is just stuffed. And the way to fix it is to do an i3 config reload. So I've got a hotkey I can hit to reload my config. So every time you resize VirtualBox, you need to, because the graphics go screwy again, you need to hit the reload hotkey, and that fixes it. And I had started OBS, and I had gone to the stream starting soon slide and hit the start streaming button, and I had resized VirtualBox, so I did a reload, and then that sent OBS totally sideways. So for tonight, we will not be resizing VirtualBox. If we accidentally resize VirtualBox, then we can't use IDA because I can't get it to behave without bouncing OBS and cutting the stream in two, which I don't really want to do. So if that happens, we get to learn how to use radar on the fly, which will be a lot of fun. The joys of computers. I don't know why any of us work with them. They're ridiculous things. So that's been my my last 24 hours. OBS, I had to reconfigure my mixer, I had to reconfigure the audio, had to reconfigure some bits and pieces in OBS. I did manage to salvage most of my config. So if there's any video issues, any audio issues, please let me know, because they are very likely to happen. Alright, now that's out of the way, the part of the night I've been most excited for, well, I mean, the binary is the second most exciting thing, but Parks bought me a bottle of whiskey and brought it to me at KiwiCon, which was very unexpected, very not needed, but so very much appreciated. So thanks, Parks. I'm enjoying a glass of whiskey tonight. Oh, and she's a cracker. She's a good one. So cheers, Parks. Thanks very much. Alrighty. As always, if you need me in chat, please use my name so I get a little ding up the top here. Yeah, rebooting Linux kills your shit. Rebooting Windows fixes everything. Yeah. Well, I mean, it was the hard drive must have failed. It was bound to happen. It just took a reboot to really unearth the issue. Blame System D. Yep, blame System D. So, what we're doing tonight, as promised, is a stream that I've been looking forward to, well, since I started streaming. It's actually, before I started streaming, was a blog post I had been looking forward to writing for a long time. OJ kicked out this awesome, I think it's awesome, awesome challenge called bin2json in time for B-Sides Canberra. So I think it was early this year that he punched it out, and he gave it to me and said, hey, can you please play test this? I want this to make an appearance at B-Sides Canberra. I said, yeah, sure thing, and gave it a crack, and it took me about 2 days to solve it. It's a good one, and I thought it was brilliant. So then it hit B-Sides, and it went unsolved in the CTF. And then after the CTF, I said, hey, OJ, what are your plans? Are you going to keep it and reuse it at another CTF, or am I able to do a write-up? Because I'm really looking forward to doing a write-up for this challenge. And he said, yep, hold your horses. I'm going to think about it. So it sat on ice for probably about 6 months. It's been 6 months since B-Sides. Made an appearance at the KiwiCon CTF, where I believe due to some technical issues, it was launched pretty late in the competition on the second day, which, in my opinion, was not enough time for many people to solve it. It is a bit of a toughie. On Twitter, some people have already got it. Richo's already got it, and Richo has done a really quick, but really good write-up that really spoke to me in terms of how efficient you can be when it comes to pwning stuff. I'm not going to say lazy, I'll say efficient. Richo punched out an exploit really quite quickly. He actually fuzzed the bug out of it. I won't be fuzzing it tonight. I really want to dive in and reverse engineer it because it's a really interesting bug class, and I want to go into a bit of detail as to how it works. But Mongo has also solved it. OJ, some other people have solved it, yeah? About how many do you reckon have solved it so far? And it's been about, what? They did it in about 24 hours, so it can be done quickly, especially if you chuck a fuzzer at it, but it took me quite a while. And so hence it stood the test of KiwiCon as well, and OJ has then tossed it out to the wind into the internets, put it on the tubes and sent it on its way and said, hey everyone, have a go at it. So I wanted to have a go tonight. So yeah, full disclosure is I have already pwned it. I pwned it earlier this year, so I know exactly what the bug class is. I can't remember the exact details of where and how. So what we'll do is we'll jump into it. We'll kind of take a bit of a meander through the binary, explain how a few bits and pieces work. Then I'll take us over to the section where I think the bug was. I know what the bug is, so it should jump out at me. And we'll put together an exploit, and it should be good fun. If there's any questions as we go, please yell out in the chat. Again, use my name. I'll get the little dings. OJ, I believe, is going to be sticking around for some of the evening, so he may be able to help me out with some of the questions, so I can put my focusing hat on. If I know he has to wander back and forth. So if he can't answer, or if he's not here to answer, I will jump in. But otherwise, let's give it a go. I think there's all throughout this post, there's bin2json is linked to a tarball. So we'll whack that, pull it down. Hopefully this makes sense. Hopefully I'll launch that in the right container. There we go. Twitch, bin2json. So you get a tarball. If we unpack that. I'm still getting used to typing with this honking big microphone in my face. And what do we get? We get a readme, we get a binary, we get the tarball, and we get sample.py. So if we have a look at the readme, which by the way, I believe is reproduced here. I think this is just a readme. Yeah, this looks like the readme. The link to this blog post, by the way, is in the description below, so if you want to grab a copy and follow along, then please do. If you want to refer to the readme at any time, please do, because there's some nuances as to how the protocol works. So we'll go through this, but if you need a reminder of what we're doing and how we're doing it, then the protocol specification in the readme may be what you're looking for. So we get a readme. Back in the days of quality enterprise software, a company called Totes McPants had a proprietary solution, blah, blah, blah. It's the Simple Human Instance Tracker. Blah, 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 web scale something. It'll happily translate SHIT's proprietary data format to a relatively clean JSON format. So it looks like it's a bit of middleware that does some translation between a binary protocol and JSON. So the format's pretty simple. The transition layer extends it slightly by providing a very simple command style interface. Once connected, the system waits for a binary blob to be sent, which contains a number of actions. These are the two actions. Create person is an action value of 0. It's intended to create an instance of a person using the binary person format. Print, an action value of 1, will print out all the created people in a nice JSON format. So it looks like we can connect to it, feed it an action value of 0, feed it a binary formatted person. It will then add it to the collection of people. We can then ask it to print using an action value of 1, and it should dump out everyone it knows about in a nice clean JSON format. Action values are a single byte in length, so they're not full 32-bit, they're just single bytes. So when you create a person, there's 3 types of persons available. You can create engineers, we can create hackers, we can create managers. So these again all have different numbers that correspond to each one, so they've got 3 different numeric codes. And how it works is each type of person has different attributes. So a person that's an engineer has a single value that represents how humorous they are. It is 4 bytes in length. So for example, if you wanted to create Uncle Bob, an engineer, then you'd send your byte, which is 0x1. Then you'd send the name padded to 512 characters. Then you'd send a little endian 32-bit number, or an integer, 32-bit little endian integer, that explains how humorous the person is. Or you can have a hacker, which is an extension of engineer, has an extra field called handle, which is 256 characters long. So for example, you could send 0, Rob Fuller, padded to 512 characters. You could then have a little endian integer for how humorous the person is, and then you could have their handle padded to 256 characters. Finally, you've got a manager, type value of 2. They've got an extra 4-byte integer value that represents how much of an arsehole they are. So you'd send number 2, Larry Ellison, padded to 512 characters, and then a 4-byte little endian integer that explains how much of an arsehole they are. Blah blah blah, to create a person, each of these byte strings must be prefixed with 2 other bytes that represent. So you need to prefix it with the create person action, which from up here we could see was 0, and then a flag that indicates whether the entry should be added to the head or the tail of the internal list. Blah blah blah. And then when you print, you send 0x1, and you probably just get back a bunch of JSON. Once connected, blah blah blah. You send a series of translation payloads. Blah 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 blah. Okay, so you got a prefix. Okay, so you can send a series of payloads. Each payload contains a 4-byte size header, followed by the payload length. OJ, should that just be payload? Each payload comes in the form of an action, so a typical payload might look like a 4-byte length, and then you do this, which might be create a person, create a person, create a person, create a person, print them out. So you can kind of tie multiple create persons and multiple print actions together. You just got to prefix it with the length of what you're about to send as a bundle of actions. We get a sample.py file which shows the application in action. System assumes that every team and business has at least one hacker. If no hackers present in the list, printing won't do much. Goal, shell the target, get the flag, ASLR is not enabled. Alrighty, so that's the readme. If we have a look at sample.py, sample.py is a very simple example of how to talk to the SHIT translation service. So what this Python script is doing is it's pulling in some libraries, the socket library for connecting to remote hosts, and the struct library for packing and unpacking integers as byte strings. So you can take a number, turn it into a string of bytes, which is little endian, then you can do the reverse as well. But it looks like we're only doing one way here. We're only packing stuff, not unpacking it. Then we define a few functions, which what they do is they provide helper wrappers around struct.pack, because remembering this is garbage. And so this one's going to pack a integer to a little endian 32-bit integer. Capital L meaning... That's interesting. What does little l mean? Python struct. It's not that important, I just want to... I'm curious now. So this is the doco for Python's pack. So big L is an unsigned long. So it's a 4-byte integer. See, I normally use capital I for an unsigned integer. Unsigned long looks pretty analogous. Okay, cool. And then we've got another one for a single byte being packed. And then we just kind of set up our magic numbers. We know that names must be padded to 512 characters. We know handles, or the hacker alias, has to be padded to 256 characters. We've then got the types, like the types for create and print actions, the types for each person type, and the two values for whether you want to add to the head or the tail of the list. We then create a hacker payload, so it doesn't actually have the create flag at the front. All it has is the 32-bit value for hacker, and then the name padded to 256 512 characters, which is padded with null bytes, byte left justifying it. We then have a value 10, which I think is how humorous they are, and then we've got a handle, which is Mubix padded out to handle size in the same way as the name. Same thing for manager. We create a manager, Larry Ellison, with a value of how much of an arsehole they are. And then what we do is we kick off a empty string for actions. We then append to it that we want to create something at the tail of the list, and then we add this hacker bundle, and then we append a create action flag, then we append the head flag, so we want to add Larry to the head of the list. We then append the bundle of data about Larry. We then append a print action, and then we create a payload, which has to, as we saw, begin with the length of the entire bundle of actions. So we pack it down to a 32-bit integer. We append the list of actions. We then just do the standard socket.socket dance, where we connect to a local host on port 1337. We send the payload, and the payload will create a hacker, create a manager, and then print the JSON. We then receive some data back and print it, and we close the connection. So if we were just to run, the last thing we got was actually bin2json itself. If we just run it and enter some garbage, nothing happens. It actually kicked us out before receiving all these A's. Now if we were to listen verbosely on port 1337 and execute bin2json, that's how it's supposed to work here. Yeah, there we go. We can connect and talk to it. So if we kick that off and then run that sample script, we're doing bin2json. If we run sample, it should connect to localhost, create the two people, and then send the print action and give us back a JSON list of JSON dictionaries, with Larry Ellison being an arsehole. We'd actually get back how much of an arsehole he is. We just get back the fact that he is an arsehole. Then we get our hacker, Rob Fuller. He is humorous, and he has a handle of Mubix. So that's what we get in the bundle. Does that gel? Are there any questions, queries, concerns about what we get before we start picking it to pieces? Does that make sense to everyone? Oh, Mongo, how's it going? Good to have you around. You can see me flounder and fail at the binary you turn to mincemeat very quickly. Good to have you here. Jack Black, good to have you here from Russia. Welcome. Alrighty, let's dive into this. Let's pull this up in IDA, so we've got it there, and we'll start playing around with it, I guess. Come on. Alright, I just saw that yeah, it's a 64-bit binary. What are the protections on it? Alrighty, so we've got no ASLR. It does have dep enabled. No stack canaries, no fortify source, partial read-only relocations. Cool. So what we'll have to keep in mind is that, yeah, NX or dep is on. Alrighty, do we have the main function? Actually, is it stripped? Nope, it's not stripped, so we get like function names and all sorts of cool stuff. Awesome. Forgot that was the case. So here's the main function, we do some stuff. Looks like here we got some cascading blocks to probably compare options of what the person wants to do. That looks like a beast of a function. Okay, so the functions we've got are create person, display all, display manager, display hacker, display engineer, and main. That looks like really all the interesting stuff we've got. So I'm guessing main is here to basically dispatch to these functions here. For example, if we go to create person, look for the cross references, then yeah, it's called from main down here. This is where create person's called. This looks like an awful spider web. So here's where display all is called. So these two blocks have these as parents. These two have this one as parents, and yeah, here we've got to compare one, jump if the zero flag's not set. So this is probably where it's kind of comparing that action flag as to what it wants to do, spitting execution down to either creating a person or displaying all. Do these loop back? Eventually. So yeah, so create person kind of looks like it flows down here, creates the person, I'm sure, and then goes back and loops, because remember, we may have a whole bunch of either printing or creating people sent within that one action packet, and then at the end of the time that it actually does that, it probably might loop back again to give us another shot, maybe. So maybe we can kind of send one bundle of stuff and then do another bundle of stuff. Otherwise, when we display all, it kind of displays all, then loops back up to probably the top of the bundle of actions processing block. So this here probably processes a bundle of actions. This down here looks like it creates people. Then we've got a big red loop here, which probably lets us give more input, maybe? Question mark? Yeah, it's going back to near the beginning of the function. So that probably, the whole function will probably loop and let us do more stuff. So that kind of gives an idea of what main looks like. Main basically just dispatches to the create people, or the create person and the display all function. And then we can see we've got the option, we've got three different functions. We've got display engineer, display hacker, and display manager. These are surely called from the display all function. Yeah. So the display all function looks like this. We put a character, probably the left square bracket. 58 hex is I think the left square bracket, which we saw. Yeah, I totally closed it. Let's quickly I'm going to quickly hack away on this sample, stuff the socket stuff. Let's go sys.stoodout.write the payload. That way you can just pipe it straight in instead of doing the whole netcat shenanigans. Run sample, pipe it into bin2json. There we go. So the display all function spits out 58 or 5, yeah, 5B, my mistake. Hex 5B, which probably just spits this here at the screen. And then we kind of look like we kind of loop through here. We can loop back up probably until we've displayed all the people. And then these three blocks here dispatch to the display hacker. No, they don't dispatch, they just kind of set up a variable with a function pointer to display the hacker, display the manager, or display the engineer. So this function will end up dispatching to those three functions to do the job of printing out the different types of people. So that makes sense. The create person function looks pretty simple. It's going to do a mem copy. The mem copy here. Apart from that, it's just a whole bunch of moves and load effective addresses and jumps and stuff. I mean, the mem copies are probably to copy the names, whereas the moves and the load effective addresses are probably just to transplant those integer values into the right spot. We malloc and memcopy, so we do that. Then we return. So somewhere in here there's going to be something that's responsible for creating, I'm guessing, a linked list. If we had the option of appending to the front or the front or the back of the list, there'll probably be a linked list somewhere. We look like we've got mallocs going on to create heap entries for each person, I'm guessing. Alrighty, let's go and create our own equivalent of sample.py. And just call it exploit because we're ambitious like that. Alright, so we'll create a tube, pwn.process, bin2json, and then we'll attach GDB. Create some actions for GDB to do once it launches. So this here is a really fancy way of basically creating a string with just a letter C in it. But the neat thing is we'll be able to do things like break main, and then it will stitch these together with new lines in between them so that GDB will execute them. It'll set a bunch of breakpoints here and then continue the process. That comes later. I'll quickly do pwn.context. Just set up pwn so it knows about tmux. That should do. Then we'll just go t.interactive for now. Alright, so ptrace operation not permitted, question mark. Is Docker going to be a jerk and not let me actually attach to stuff? I think I've seen this before. Maybe Docker's changed on me. Ptrace not permitted. Alright, I'm going to go quickly hack on my Docker config to see if I can punch a hole in it to let me do that. I'll be back in one. Actually, no. Let's just go to the old test pattern while I fix my shit. Can ptrace is now true. Oh, and that totally kills Chromium. There's nothing important in there, I don't think. Alrighty. Let's try again. Twitch. bin2json. Ptrace not permitted. Hooray, Docker's gone and totally screwed me. Yeah, Docker shakes fist indeed. Hey, Alex the Blue Frog. OJ's totally right. I am probably the furthest from a programmer that could be imagined. I'm currently using Python. We're just using it to write an exploit for a program that the Colonial wrote. Why is Docker not letting me debug stuff? Can we launch it directly inside GDB? Wouldn't be a stream without my freshly built machine being a nuisance, would it? Let's try gdb.debug. You give it the args. You probably can't send. Bleh. Probably can't do this trick with it. Ugh. Really? Is it GDB-P? P-trace not permitted. Pow. I'm just going to go check that tweak I made really quickly, just to make sure I didn't do something totally stupid. Because I'd really like to be able to attach my debugger to stuff. Can ptrace is true. Yeah, so I'm giving it like capadd sys ptrace. That should be being nicer. Can someone look into whether Docker has recently changed and if there's any new issues with people not being able to use GDB to attach to stuff inside a container, please? Check proxys kernel, blah 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 blah. Maybe it's because you have a kernel, not Docker. Echo 0 to that. Let's do that. Yeah, maybe it is the new kernel that's doing that. Thanks for that, people. Let me get back to where I was. Let's clear this screen. Alrighty, we're back. Let's check what this is. 0. Do you reckon I can twiddle that knob from inside Docker, or would twiddling it outside Docker be the way to go? Probably do it outside Docker, question mark? Actually, that's what it is, outside Docker. And my phone's... yeah, so it's 0 outside Docker. My phone's ringing. Actually, you know what? I'm going to take a quick breather and answer my phone. 1 sec. Alright, good thing I checked. That was an emergency. My brother wanted to know if I needed anything from McDonald's. Go 1 sudo t bang $. You reckon that's going to do it? Hey! Thank you so much, Mongo and Immerse. Thank you for that. What version of Docker am I using? Does Debian use? I don't think Debian uses SE Linux. Hey, how's it going, Dover Yawn? Let's see if this worked. Twitch. Alright, Mongo totally just socialed me and just broke all my shit. If we just run bin2json. Can we attach to it? Question mark? Nope, ptrace not permitted. Do I need to bounce the Docker container? Oops. CD, Twitch, bin2json. Ptrace not permitted. Was it 1 or 0 I should have put in that file, by the way? Did I just like turn security up or down? Okay, so you're supposed to put it on 0. Awesome. Yeah, echo 0. Okay, yep, cool. So I just went and actually cranked security up. as far as ptrace goes. Alright, so yeah, maybe this is a Docker thing. How can we alright, I'm going a bit YOLO. Let's get rid of this nonsense. Let's get rid of that. Let's get rid of that. Let's try the other GDB approach. Because it looked like we could do GDB. HID. Like, you can start something up inside GDB, that's fine. You just can't attach from outside the process, which is a total pain in the butthole. And I know what I'm going to be looking into off stream. It's going to be that. Spoiler. It's going to be that. T equals pwn.gdb.debug, was it? Oh, I totally killed Chromium. It's not at all what I wanted. pwn.gdb.debug. Oh, it totally does take that execute argument. Hooray! I mean, starting something up directly inside GDB, what's it going to do to us? It's going to turn ASLR off. That doesn't matter because ASLR is off anyway. I don't think it'll muck with NX. It may kind of muck a bit with the heap layout, which I don't think is going to matter for this one. I think we should be okay. Just YOLOing it and actually launching inside GDB. So we'll bring this back. So we'll debug bin2json. Execute equals GDB CMD. See how that goes. It's not what I wanted. Execute equals none. What's it complaining about? Okay, so it looks like GDB server is actually kicking out an error with the word permitted, probably not permitted. So can we do pwn.context log level equals debug? And got like nothing out of it. Okay, so GDB server, blah, blah, blah. Do I have GDB server installed? Yup. Let's go that. Let's go that. Let's go that. Huh. But we can totally go GDB bin2json. Alright, how are we going to do this? We're going to just rig it up with netcat. Yeah, we're going to rig it up. Actually, we'll rig it up using socat. Because I don't use socat enough and I should. Do I have socat? Do I have... Yep, I got netcat, so socat. You know what? Let's just be grown-ups about this. Docker caps maybe. Yeah, so I'm not going to do privilege. Do I have? Yes, I do. that is what I turned off the first time I went to the test mode for the TV pattern thingo. I did do cap add sysp trace. So I'm going to cut and run on that one, and I'm going to look into it tomorrow. And let's go and YOLO some SOCAT and duct tape to get a debugger set up. Alrighty, do I have SOCAT now? Yep. Twitch, bin2json. I don't care about that, I don't care about that. Accepts connections and forks a new child process for each connection. Alright, that looks annoying. Let's do netcat. While true, do netcat LVP 337. Execute bin2json. Done. Alright, so we should be able to just go netcat. Yeah, so we can do sample.py, pipe it to that. Yep. Nope. Nope. Yep. Nope. So it looks like when we forcibly disconnect, netcat's not given two shits. How do we make netcat die after actually? Is it like a serve forever thing I should be doing? Man, this is so not what I thought I'd be doing tonight. This is the fun stuff, right? Watching someone fail and get totally uncomfortable on stream. -Q0, because we should be sending it at NeoF on stood in. Yep. Nope. -Q1. Yep. Nope. Why is netcat not like dumping my connection and letting me connect again? All good. Cheers, Parks. Setcop unconfined. SOCAT, blah blah blah. Sweet, thank you MS, that's what I was after. Sweet. Sweet. Alright. Now, what we'll do is we're not attaching GDB to anything. T equals pwn.remote. So we're going to connect, and then we're going to not debug anything, and then we're going to go print. Why am I thinking this is going to work? If I'm going to now prompt me to go and attach GDB, why did I ever think this would work? So what I'm thinking of doing is we'd end up doing something like this, and then go psef grep bin2json, and then gdb-p that. Of course it's not going to work. Alright, seccomp unconfined it is. And then failing that I'm going to do privileged. Because why not? What's the worst that could happen? Am I right? Alright, I'll be just tying. Oops, wrong button. Let's do. Should we just do seccomp? Should we just do privileged? Try on the container without the seccomp app armoring by default. Let's do unconfined because I don't want to do privileged. Security ops seccomp. Okay, let's do that. Just going to YOLO this one into my script. argv plus equals that. Security opt seccomp blah. argv blah. Unknown flag, security opt, blah blah blah. Did someone lie to me about what the syntax of that was? I've got it here somewhere. Security. Oh, okay, it's got to be, yeah, of course, two different argv thingos. Let's try that. Alright. Let's go like 8th time lucky. Hooray! Whoever said seccomp unconfined, I'm buying you a beer. Alright, we're back on track. So I can find a new and interesting way to fail. Alright, let's go and put the GDB back in. Let's get rid of that. Don't need the log level debug. GDB command is continue, attach, interactive. Alrighty. So then if we just go and send like a bunch of A's, then the process exits normally. And then we kind of do the standard just to prove it's not going to work. T.sendLine A times like a bajillion. And we get like a whole bunch of no happy. So it's not just a straight up send the A's and win. We need to implement some of OJ's sample stuff. I'm going to go and steal this. I'm going to steal the hacker. Actually, no, I'm going to steal everything. There we go. It's not what I wanted. Alright, cool. That's what I want. So let's, instead of sending a bunch of A's, well we won't then, but let's go and go T.send. T.send, I'm guessing not send line. Payload. P32 is not defined. Pwn.p32. Does pwn give us P8? Yep. You know what? P8 bracket with P8 bracket. Same thing for 32. Alright, so we save that, we run that. There we go, we get some JSON output. And you'll notice that the process is still listening. It hasn't actually shut down. And this T.interactive has given us an interactive terminal with which to interact with that tube. So what we could do is send the payload a couple of times. And we get back a bunch of JSON. So that's kind of cool. We get multiple shots actually sending these length prefixed payloads. some good whiskey. So what are we going to do now? I mean, do we want to see if we can max out these name fields, or do we want? We should probably wrap these up into some functions. Let's go and define make hacker. Hacker's going to have a name, humor, handle. You get the name and left justify and pad it out. You get the humor and pack it. You're going to get the handle and pad it out. Now we can do Mubix equals make hacker. Rob Fuller. He's a funny dude. I'll give him 255. And his handle is Mubix. So now instead of hacker, we're going to do Mubix. Send that off. And we can't concatenate some stuff. Oh, we didn't actually return anything. Duh. Did I not send stuff? Yeah, I did. Where is that gone wrong? Return handle. Hacker. There we go. So now we've got hacker, Rob Fuller. Humorous is true, handle is Mubix. Okay, cool. So we've got a function that builds hackers. We might as well go and create one for the rest of them as well. Make manager. Managers have a name and an asshole level. So manager starts off with a 32-bit integer of manager. Then it has the name, left justified out to name size, padded with null bytes, plus pwn.32-bit integer for how much of an asshole they are. We return the manager. Go and copy that. That should be all we need. Then we can go and, instead of manager, go Larry. But so the script broke because Larry's not a hacker. Larry's a manager. But we just like accidentally caused some sort of interesting crash. What happened there? How bizarre. That's not... No, that's not plain text. That's not text. Pretend we didn't see that, hey? Alright, so we've got... we had a bug. What was the bug? I think I just fixed it, didn't I? That was hacker, but it should have been manager. Yeah, okay, cool. So now we've got Manager is Larry, asshole is true. Okay, cool. So that's the manager done. We should probably implement the last one as well. Engineer. What were the conditions? We had to have at least one hacker. Yeah, if there's no hacker present, nothing good's going to happen. Alrighty, so an engineer has a type value of 1. We've got make engineer. Engineers have a name and humor, because hackers are extensions of engineers. Engineer has how humorous they are. Yeah. So we've got engineer equals empty string, engineer plus equals phone.p32 engineer, which is going to be number 1. There we go. Engineer. We've got what the name, left justified, out to name size, pad it with null bytes. If anyone's confused about what this here is doing, what it is this. You've got like 3 A's. If you want it left justified to length of 256 and you want to pad it with the letter B, that's what you get. You get 3 A's and then it gets padded out to exactly 256 characters long. There you go. So what this here does is equivalently, it takes the name, and then to make sure it is exactly, no, at least, because I mean if we went and tried to pad it out to a length of 2, then we get length of 3. So it makes sure it's at least name size characters long, and if it's not, it just pads it on the right with null byte. Is what that is doing. So engineer gets the name. Engineer, we append 32-bit integer of how humorous they are. And then return engineer. So now we've got OJ equals make engineer. Because I don't know if anyone knows, but OJ used to be a software developer. We've got OJ. How humorous is he? Nah, he's a funny dude. Let's give him 128. Yes, you're less funny than Mubix. I called it OJ. I said it. I went there. So we've got OJ as an engineer. So now what we can do is we can go and put him. So we're going to create something at the tail, then create something at the head, then let's go and put OJ at the tail. Actions plus equals pwn.p8. Create. Pwn.p8 at the tail. Actions plus equals OJ. Then we're going to print them. Let's only send the payload once. We don't need to do it 5 times anymore. There we go. We've got an engineer. His name is OJR. He is humorous. So now we've got, let's just triple check. We created Mubix at the tail. Then we created Larry at the head. So Larry came first. Rob's at the tail. And then we created OJ at the tail. Puts him last. And we get the JSON back. So that's how the app's supposed to work. That is some quality enterprise software right there. So now in terms of the bug, either I can go stumbling around through the binary, through IDA for half an hour and kind of say, I wonder if the bug's here, I wonder if the bug's there. Or if we're keen for getting it on with so we can start building the exploit, we can jump straight to the bug if we prefer, which is what I'd prefer. So to recap, we've got the main function here. Yeah, you know what? This is a lot beefier than I remember. I'm not going to explain the loops and explain. Bleh. I'm gonna jump to the bug. Let's have a what are we gonna, let's look at. We've looked at like create person. Is it really that interesting? We mem copy some stuff that could have been an overflow there, but there's not. There's no overflow there. We malloc stuff. We actually check the return value of malloc, so that looks pretty normal. We copy stuff. Yep, and we'll end up returning 0 if malloc failed. So as long as the consumer of this cares, then that's fine. What's this red arrow on the left do? Compares EAX to 2, which is probably the person code. And if it's greater than 2 or equal to 2, what are the people numbers? 0, 1 or 2. Compare EAX to 2, jump if less than or equal to over here. So if it's greater than 2, so if it's 3 or above, we go down this red trail. And we zero out EAX to indicate failure and return. So that's probably not at all interesting, which means that this 0 here is probably handled just fine as well. We're checking return values for create person. Compare with 0. Yeah, we're checking return values. So that's not that interesting. So look at display all. If we look at these, display engineer, this looks digestible. We make a decision based on how humorous they are as to whether to move the pointer to the string true or false into ECX, and then we kind of do a printf. The format string looks like we don't control it, so there's no format string bug there. It's only doing a printf, it's not copying strings around, so that looks boring. Displaying hackers. We check something to see if we should make a decision to put true or false into ECX. That sounds boring. We've got a format string, which we don't control, that gets printf. That looks boring. Displaying managers. Looks boring. Jumping to display all. So how does display all work? We should probably dive into display all and actually explain this one. I'm going to take a quick 5-minute breather. When we get back, let's pick apart display all and see what's going on. So if you need to take a break, now's the time, and we'll reconvene in 5 minutes or so, and we'll catch up then. I'm looking forward to it. Alrighty, let's get into failing and reverse engineering the display all function. As Mongo told me, I should enter cheat mode by pressing F5. Unfortunately, I am poor and I don't have the decompiler licenses for either. If I had the F5 button, our life would be made much easier. But we get to get our hands dirty and make stupid decisions and stupid life decisions in reverse engineering assembly, make mistakes, and then figure out where we made them. And that's fun as well, right? So we've got this display all function. What's going on? We can see here that we're pushing 5b to, we're doing an fputc. If we look at the man page of fputc, puts a character, so it takes the character and the file descriptor to print it to. So we're putting 5b into EDI, which is the character to print. We're putting stood out into racks, then racks into RSI. So we're printing hex 58 to stood out. That's just printing out the on a scale of 1 to 2. I panicked and I was wanting to get back to stream, and I'm saying, no, I don't want McDonald's, when really I wanted McDonald's. So no McDonald's for me. I'll go hungry. So 5b, man ASCII. 5b is definitely left square bracket, yeah? Yep, so 5b is left square bracket. So print left square bracket. Then what we're doing is we're comparing the local variable 338 to the number 0 and jumping if the zeros flag all the way down the left hand side through this green arrow to moving stood out to racks, moving racks to RSI, moving 5D to EDI. 5D is probably going to be right square bracket. 5D is right square bracket. And we're doing an fput-c, print right square bracket. And then we're flushing stood out. Yep, because stood out's still in racks. We're putting stood out back into racks because compiler optimizations, what are they good for? Actually, you know what? fput-c probably would have messed up our registers anyway. So we're flushing stood out to actually cause printing to the screen. And then we're winding up the function. So that if 338 var 338 was equal to 0, it would print like a JSON empty list. So var 338 came from RDI, which is a parameter to the function because we're in x64 land. Like, how is display all actually called? Putting something in RDI, putting something in racks. So we're putting var28 into RDI, and then we're getting RDI, putting it in here, and then we're comparing that to 0. So it sounds to me like this here, RDI, the first and only argument, I think it was the only argument to this function, sounds like the number of things we're going to print. And to me it sounds like it's a local variable inside main that stores how many people are known of to the program. If we highlight var28 and have a poke around. Okay, so the top of this function, we reinitialize it to 0. But I thought this loop here was like an opportunity to do more than one thing at a time. Oh yeah, because as we saw before, when we do payload multiple times, like the list of things getting printed doesn't grow each time. Like in the first one we've got Larry once. In the last one okay, yes, we've got square bracket, square bracket, square bracket, square bracket. So the list isn't growing, the list of people isn't growing. So it looks like on each cycle through the main function, we can add people, we can print people. It's not actually creating a ever-growing list. Each time we kind of loop all the way back up to the top of main, we start with an empty list. So that makes sense. So this var28, if we scroll up to the top, we saw it got initialized to 0. I'm guessing it's going to get incremented each time we create a person. We go create person. We come down here, compare that to 0. Move racks. Maybe it's to do with the head and tail of the list. Maybe it's not the number of people. Well, we know that when it is 0, we bail out of that display all function. So what's var28? And do we really care? I know what the bug is. I don't think we really care what var28 means. That term. So it looks like 28 and 38 are maybe pointers to the head and tail of the list. And so maybe var28 is the head of the list, and so inside display all, if it's 0, which means that, like, if we've got a null pointer there, then that means that there is no head of the list, which means that the print people function bails out. So maybe var338 is it's actually a pointer. Move that to RDX. Move SQ. Okay, so yeah, here we can see that it's moved into racks, and then racks gets derefed plus 200 hex. So it's actually not a count; it's a pointer. I'm just gonna go out on it's gonna call it a person pointer. Stuff it. That'll do for now. Pointer person. We know that it probably points to people at some stage or another. So that's, if it's 0, then that means if it's an old pointer, then we've got no people to print. So then we bail out down here, close off the list, and return. Cool. So that's, yep, that's that. Cool. Otherwise, if there are people, if there is at least one person to print, we go down here. So what have we got in here? We're moving that pointer to the person into RDX. Moving a different variable into rack, so we're putting RDX into RSI. We're moving 64 into EDX. So we're putting this into RDX. Putting the pointer that's in RDX into RSI, and then doing like nothing with it. Yeah, nothing. Who needs compiler optimizations? Who needs a compiler that actually stuff the cyber polar bears? Let's just burn the megawatts doing nothing. Unless RSI and stuff are used in this move SQ. What is in move SQ again? And I've lost Chromium again. Okay, so RSI is being used by the move SQ to shift some stuff around and move some data in memory. My bad, it was useful. And we've got a rep here. Does rep mean it's going to do it RCX times? Question mark. Of which we're doing OX64. We're doing 64, the Q word. So 64 times 8 bytes. 512, is that the length of the name? Yep, name size is 512. Okay, so it looks like we're copying 512 bytes worth of name from the beginning of the person record to RDI, where RDI from RSI to RDI. RDI is racks. Okay, cool, so it's a local variable. So we'll call this person name. So we're copying the name from the record to a local var. Copying the person's, copy the person's name from the person record to a local var. And so we're actually doing a rep movsq, so it's not like it's a null terminated thing. We're moving exactly 512 bytes worth of name. And is person name big enough to hold 512 bytes? It's like a pointer. Difference between these two here is 8. So is the person name actually a pointer? Alright, so what's going on here? Ah, thanks Immerse. Yeah, good call. Chris, no, I don't document my desktop / Docker setup. I did have a stream where I chatted about kind of how to do it yourself, because I think that it's a very worthwhile exercise. I think if you're looking to, for example, as I use Docker, it's to replace Kali. I kind of got sick of booting up a fat ISO full of a billion tools that I never use. For example, I don't do wireless, so I don't need the wireless tools. And it's just kludgy having a VM. I'm much happier having a Docker container. One which I now can't do ptrace attaching and debugging and stuff in, which annoys me. But that's why I created it. And I think it's a worthwhile exercise to actually identify the tools that you use and go through the process of building out a Docker file that collects them all from all the corners of the interwebs and installs them in a way that makes sense for you. So that's why I don't actually publish my Docker setup. Also, my Docker setup is garbage, and I wouldn't wish using it upon anyone. But it's something I'm always working on. So I think it's a very worthwhile exercise to go and build your own Docker file that does what you need it to do and nothing else. You can press R on the OX58. Yeah, as people can tell, I'm not much of an IDA user. Press R on the OX58. Awesome. That's something I very much needed in my life. Thank you for that. Yeah, you go and spend like a bunch of money on IDA, then you don't learn to use it properly. That's what I do. Yeah, that would be a great idea, wouldn't it? Wouldn't it, Pritch? SWAT pizza. Alrighty, let's keep making poor life decisions with our reverse engineering. So what is this rep mov sq actually doing then? And is it important? Probably not, but worth doing. Oh, I'm going like totally the wrong way. If person name is at -320 hex, and something else is at -328 hex from EBP, then no, this is not 8 bytes wide. It is 320 bytes wide. OX 320 bytes wide. Right. So maybe it's not the person's name. Maybe it's like the entire, a huge slab of space for everything about that person. Maybe. What is OX64 times 8? What is that in hex? OX320. That matches our OX320 here. So what we're doing is we're basically stuffing this entire local variable with probably not just the person's name, but maybe the entire person record question mark. Like maybe we're actually going and getting more than their name. We're getting their name, their handle, their humor values. So this is a pointer to a person. Let's go and call this person. Let's call it person. It's funny how when you say a word enough, it doesn't sound like a word anymore. Person. We've got one variable left to discover the meaning of. And this here's why you go and buy the decompiler license, by the way. Sorry, I was just off in my own little world there going, hang on, did we fix that GDB problem? Yeah, we did fix the GDB problem. Might be worth actually setting a breakpoint on something like this here, because what we're doing is we're moving... what are we doing? We're grabbing the pointer to the person, putting it in racks, then we're moving the keyword at offset OX210 into that record, into racks. Then we're testing racks against racks, and then jumping if the zero flag is set down to here. Otherwise in here, power of R, boom, comma, ha, neat. We're deciding to put a comma in. So what, which field in the person record are we fishing out that could determine whether we put a comma in or not? Because you'd use a comma in between people, right? So we're currently, what, have we printed the curly brace yet? The curly brace is probably printed by the actual, yeah, the printf here. Okay, so the curly brace is not the job of the display all function, it's actually the job of the display particular person functions. And then you'd use a comma in between these people entries. So this record here might be some sort of count as to how far we are into the list, and if it is 0, then we don't do the comma, otherwise we put a comma in between each person. Yeah, so I'm guessing at offset OX210 there's probably a field that indicates what the person's position in the list is. And then the linked list probably has to, when we go and slot stuff in at the beginning or the end, it probably has to go and actually fix all those fields and everyone else, maybe? Maybe. I don't think it's that important. I think we can skip over this here for now. So then what we're doing is we're doing a cascading set of blocks. In each block, we're actually going and fishing out the field at offset OX200 into the person, because we first of all get the local variable called pointer person and put it into racks, and then we deref it at an offset of OX200 and get the field, the keyword, no, the D word field at that address, the 4-byte field, put it into EAX, then we test EAX, and if it's 0, we'll go down the red leg, down to moving offset display hacker into var 328, otherwise we go down here. Then we do the same thing again, we go and fish the OX200 offset of the person, and put it into EAX, and we compare EAX against 2. If it's 2, we jump if it's not 0. Yeah, we've got, yeah, I'm an Aussie. I don't think Mongo's an Aussie, but there are a couple of us here otherwise. Unfortunately, we get to share a continent with me. I was going to tease OJ, but I'll tease me instead. So we're comparing EAX to 2, and then jumping if the 0 flag is not set. What does compare actually do? Just so I can get this the right way around. I mean, we could look at the code and then go back and check the actual values in the README and kind of go, oh, well, it probably means this, but I should learn these things. Does a comparison between arg1 and arg2. It's a signed subtraction of arg2 from arg1, the results of which blah blah blah, blah 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 blah. What does it do with the 0 flags? I guess it sets the 0 flag to 1 if temp equals 0. So if the two values are equal, it sets ZF to 1. Okay, so a compare will set ZF to 1 if they're equal. So we compare EAX to 2, and then jump if not 0 down the green leg. So if it is 0, which means these were equal, then we go down the red leg, which puts us here. So if EAX is 2, so if it was 0, it's a hacker. Was the code for a hacker 0? Yep. If it's 2, we went down this leg, it's a manager. Was the code for manager 2? Yep, it was. Otherwise, finally, we do move the pointer to the person to racks, get the 200 offset, put it into EAX again, matches the same as these, compare it to 1, jump if it's not 0. So if these two were equal, then the 0 flag gets set. And if it's not 0, we go down the green leg. So if EAX is 1, we go down the red leg to here, where we put the offset to display manager into RBP plus OX328, or minus. So we've got a local variable here which is getting populated with offset to, these are actually offsets to the functions, like these are actually function addresses. Like if we double click on this, we get sent to the display hacker function. So these are basically populating this variable here with a function pointer that will be responsible, I'm guessing, for actually doing the printing of this particular type of person. So this cascading set of blocks here, I'm going out on a limb here, but I think it's a pretty safe assumption to say that at an offset of OX200 into a person record, as it's being stored in memory, there will be a D word or a 4-byte, 32-bit integer that will be either 0, 2, or 1. That will then, based on these compares, these cascading blocks, actually set var 328 to be a function pointer. So let's just rename this to be person printer func pointer. So you know what? Let's go and actually be grown-ups about this. It's a function pointer, which is the person printer. Alrighty. And finally, if all these three blocks kind of get cascaded through and the value at offset OX200 of the person record is not 0, 2, or 1, we've actually got this sneaky little, you can see it there, that didn't help at all. That doesn't help either. You can see this highlighted leg here, this green leg here. It wraps all the way around here to this block here. So, if we manage to fall through all these three blocks, and the person type wasn't 0, 2, or 1, we actually avoid setting this local variable completely. We follow this leg all the way around down to here. And down here we can see that we're moving the function pointer, which is the person printer, into racks. We're loading the effective address of RBP plus person, which is the copy of person that we made, into RDX, moving RDX to RDI, and then we're calling racks, which makes sense. You know, we have just put a function pointer into racks, and this function pointer was basically set according to these cascading blocks to one of the three options: display hacker, display manager, or display engineer. And then we kind of go and put that local variable back into racks, set up some arguments, and then we actually call the function. The issue is, what happens if we manage to go through these three blocks, and then we take this sneaky little leg that goes around the side here, and we avoid these three blocks where it actually sets the function pointer. If we then move a local variable into racks and then call it as a function, but we never set that function pointer, what will happen? If anyone's got any ideas, and Mongo, OJ, and Immerse, you're not allowed to play this game. If anyone's got any ideas as to what would happen if we managed to not have these three blocks happen, if we kind of skirted around the edge of this call graph and ended up in this territory where we move a local variable into racks and then call racks as a function, what's going to happen? I want to hear some thoughts if anyone's got any ideas. Twitch tells me there's 38 people in the room, or at least watching. They may not be signed in. So there's 35 people who can play the game. Are we just gonna make Justin do all the hard work? Or are we gonna participate? Because I reckon what's going to happen, if no one's going to play my game, is that if we manage to avoid these 3 blocks here, execution goes down this leg here and then moves a local variable into racks and then calls it, then there'll be some uninitialized data that was left on the stack from a previous function, you know, kind of some turds that got left behind from some other stack frame that was living there. And as that previously called function got wound up and it returned, it's not like when you do a return you go and kind of scrub the stack upwards from you and clean up your own stack frame. You just kind of leave all your turds hanging there for someone else to deal with later. Because when someone else comes along and uses it for a stack frame and for local variable storage, they're just going to go and write their own stuff over the top. You don't need to clean up after yourself. You don't need to zero it out or wipe it. And it's just memory. Like the stack goes up and down and up and down, and when it goes up again, that stack frame, the old contents are still there. I mean, it's not going to be there if your operating system's any good. I don't think you'll get. I'm almost certain that when you start a process, you'll actually get a clean stack. But during the actual invocation of one process, as the stack pointer floats up and down and stack frames get created and destroyed, that destruction doesn't actually clean anything up. It leaves all the data there. So I reckon a previous function would have executed. It could have left some turds there, which will be just coincidentally in the same spot as this function pointer. Because if we click on it once, it goes yellow. If we scroll up, you can see here that it's highlighted yellow here, but that's just IDA kind of explaining the function for us with the different function variables. If we look at all this stuff here, it's never accessed or modified. They're only modified in these 3 blocks here, used in this block, which we can get to by skipping around the outside of these 3 blocks, and then never used again. This is what's called an uninitialized local variable, or an uninitialized variable. And for example, actually, let's go and just chuck it in Twitch bin2json example 1.c. Now you all get to laugh at my horrible fumbling through trying to write C. If we call foo, we go int foo. Do a printf, we'll go char buff 64. Like, I don't even know if this is going to compile. We can give it a go though. Let's go and print out buff as a string. Let's go and set buff to be a local variable. Let's not put anything in it. And then printf it and then return 0. If main then calls foo, it's going to come up here and execute this. This may not even compile. We'll have to see. Or maybe we'll have to tell GCC to shut up and do it anyway. But this here is use of an uninitialized variable. So we haven't initialized the variable. We've declared the variable and said that buff is a 64-byte long character buffer. But we haven't actually put anything in it. We're just going to printf it anyway and be like, you know, YOLO. We'll just print it. Yeah, this here is use of an uninitialized variable. It's actually a vulnerability. It's a bug class. So you've got buffer overflows, of which you've then got stack buffer overflows, heap buffer overflows, so on and so forth. You've got use after freeze, you've got double freeze, you kind of got all these crazy heap ones. Uninitialized variables is actually a bug, and it can be an exploitable vulnerability in certain cases. Let's see if this compiles. I'm curious. bin2json examples. Ha! That compiled. Awesome. So if we run this, what's going to happen? Let's go and punch it into XXD. because I'm sure we could very well stand to get garbage binary data out of it. That was a bad decision. we got 1 byte. There's probably null bytes and stuff on the stack. Let's instead do, let's go printf buff is that. Let's do integer num. And we'll go printf, let's put a new line here. Num is %. X. Can you do %x for like an integer? Yeah, surely you can. Number. Let's compile that and let's run that and pipe it into XXD. Okay, so this looks interesting. We've got BUF. Actually, let's nope, that's Python. Alright, let's just trust it. We've got this uninitialized variable here, which is a number. We're just printing it out as hex, and we're getting back 0. So we've probably got a pretty clean stack, I'm guessing. When you start a process, it maybe starts off as a zeroed out stack, maybe? I don't know. But this here, what we're doing is we're printing out an uninitialized variable as a hex integer. Let's go and create a function bar. And let's char buff. Let's go and have another 64-byte buffer. Turn 0. Into bar. How does getSend work? You can tell I'm a developer, hey. GetSend gets. Is it fgetSend? How do you get fgets? This looks good. Fgets buffer, destination buffer, the size, and then the stream. Cool. So can we do fgets into buff? The size is. Can we do like size? You know what? 64. I don't know how size of and stuff works in C. I could have looked it up, but let's go and jam in 64. This may have an off by 1 error. We may be able to write a null byte outside the buffer, but it's a demo thing, so I'm doing the best I can for a demo thing. Can we just do stood in? Or do we need to like have a... Is there something that defines stood in for us, or can we just do like 1? Is it 0 for stood in? Yeah, cool. If we call bar, maybe 0 is not stood in. How do you like get fgets from stood in? Just not capitalize it? Yeah, it's going green, that means it's good. Alright, so we can kind of give a string, and it's going to get stored inside buff64. And then uninitialized variable is still 0. We probably need to give... Make this 16. 16. 1, 2, 3, 4. Copy that. 1, 2, 3, 4. That's what I wanted. So what we've done here is actually kind of looks like it's actually null terminated it for us because that's 1 byte short. So what we've done is we've called bar. Bar has let us fgets. I'm guessing fgets lets you take 15 characters and then it null terminates. What have I missed? I saw a doot. Yeah, Mongo's on it. Yeah, no, it's not going to be UAF. I would have suspected UEF as well for something like this if I had seen the ability for a command to say delete a person. Then we could have potentially deleted a person, maybe deleted a person twice and gotten some sort of double free going on and then caused all sorts of trouble. But there was no opportunity to delete someone, so I didn't. My mind kind of abandoned the UEF idea in that case. But yeah, Mongo's on this. It's an uninitialized variable. So fgets reads in at most one less than size and stores them in the... Okay, yeah, cool. That's why we're seeing one less for one than we wanted. But what we're doing here is we're calling bar, and bar is declaring a character buffer of 16 bytes. We're calling it buff because I'm imaginative like that. Then we're fgetsing into it from stdin. We're allowed to give 15 characters and then it will null terminate it for us. And we'll store the resulting input into the variable buff. And then bar is returning. And then we're calling foo. And what foo's doing is declaring a character buffer, which we actually didn't end up needing or using. And then we're declaring an integer called number. In fact, I'm lucky this didn't end up screwing us. But we're declaring a local variable called num, and then we're just printfing it without even setting it first. And what we can see here is that when we gave a whole bunch of A's as some input, we left that as a bit of a sneaky surprise, as a bit of a turd on the stack during the invocation of bar, so that when foo came along and foo foolishly used this local variable num in a printf without initializing it, hence an uninitialized variable, when it printf'd it as a hex integer, we saw our 4 ones pop straight out. So if we run it again and gave a bunch of B's, then we can see that we can leave a bunch of B's as our turd on the stack for foo to come along and foolishly use. So that's in essence what a uninitialized variable condition is, how it behaves. And as you can kind of see here, if we've got the ability to kind of leave turds on the stack of our choosing, and then later on a function comes along and calls an uninitialized function pointer, an uninitialized variable which happens to hold a function pointer, maybe we can control what goes into that function pointer. Maybe we can control a turd that got left on the stack previously, which then gets left behind, which then kind of is used later on without initialization as a function pointer. Should give us RIP control. So hopefully that makes sense. That's the bug. The bug is, this uninitialized variable. So the question is, there's two questions. How can we reach this part of the code and make sure that none of these 3 blocks are executed? We can probably do it by setting a person value that's not 0, 1, or 2, but we need to dig into that a bit more to see if there's any other curly conditions around what we have to do when creating a person, so that when this function comes along to print it out, it dodges these 3 blocks. The second thing we need to do is figure out a way to leave some turds on the stack in a previous in a function that executes prior to the display all function, but ends up having a stack frame that's in the same location. So hopefully that will become clear as we go along, but it's going to end up looking something like this, So step 1, here's the stack. Here's a stack frame. It's the only one being executed. Let's call that main. Let's say this is main stack frame. The next thing that's going to happen, let's go and make a few copies of this. It's not what I wanted. Next thing that's going to happen is some other function is going to get called, and this is let's say func1. That's func1's stack frame, and then func1's going to return, and the stack's going to look like this again. But remember, there's turds on the stack that func1 left behind. Then the next thing that's going to happen is, I've run out of little ASCII diagrams. next thing that's going to happen is there's going to be these turds here still. Is it called display all? What's it called? Display all. Display all is going to get executed. And remember, there's these turds on the stack, and then one of these is going to be an uninitialized, or the variable, which is the function pointer, and it will remain uninitialized. And this turd, which I've indicated with an X, will stay there. And then display all will call this as a function pointer, and we should be able to put X, or the turd, into RIP. So the issue is that we have to find some function that executes, that main executes, and it kind of executes in the same geographical region of the stack that display all will later use when it's executing. So that's the second challenge we need to overcome. The third thing we'll be doing is figuring out what to do with rip controller once we've got it, because as you'll recall, dep is on. ASLR is off, but dep is on. So that's going to be fun. In terms of triggering this code path that kind of takes us around the edges here, we need to make sure that the person type is not 0, 1, or 2. Otherwise, if it's 0, 1, or 2, we're going to have a boring function pointer set in this local variable, and that's not going to be fun. So if we kind of scroll up a bit, here's that common nonsense that I didn't bother looking at. Scroll up a bit. So these blocks don't even execute if there are no people. If the pointer to the person is 0. So we go down here. So it looks like there's nothing. Once we go down this path and there is a person there, then it looks like we've got no option but to make our way through this block eventually. And we could do it by skirting around the outside here, as long as the person type is not 0, 1, or 2. So that's easy. But we need to look at how people are created to make sure that we are able to create a person with a type that is not 0, 1, or 2. As an example, let's just quickly go and crank out yank 5 down. Let's go and call this person make pwn. But see, we don't know if they're going to take a humor attribute or an arsehole attribute or a handle attribute. We need to remember, by the way, we need to create at least one hacker. We've already seen in the Docker that you need to have a hacker. Whether that's true or not, we don't know. Like, let's go and get rid of the Mubix action. Comment that out. Was the Docker lying to us? Like, can you still? No. Yeah. So if you don't have a hacker, nothing prints, and if nothing's printing, we're probably not getting this triggered. So we probably need to have a hacker. Let's just make sure I'm not being dumb. And there we go. We get people again. Alrighty. So we need to have a hacker, unless I was doing something silly there. No, that looks reasonable. We need a hacker. Alright, so how do we create a person with a type that is not 0, 1, or 2? Let's go over to the create person function. Okay. So where do we see, like, at what offset was that person type? Maybe we can go to the create person function and use that offset to the type to isolate the area of code where the person type is set. Offset 200? Yep, offset 200. So if we go to create person, if we just look for offset 200, yeah, maybe these uses of OX200 relate to the offset at which types are being set, maybe. Hey OJ, good to have you back. We were just talking about you behind your back. Good things, of course. Cheers, OJ. Yeah, we've gotten to the explanation of what a uninitialized variable is, and I was proud of this. You're going to be proud of me. Where are we? Even did like a little, I wrote C. I did stuff where I actually demonstrated a function that fgets into a buffer, followed by a call to a function which printfs as hex, a uninitialized variable, and we were able to demonstrate that if you go and spray Bs, you get Bs. If you spray As, you get As. So that's where we're at. We've gone through what a well, we've identified in the program where the use of the uninitialized variable is. The fact that as long as we've got a person who is not of type 0, 1, or 2, then the display all function will call a uninitialized variable as a function pointer. And now we're looking at how to create people that have a type other than 0, 1, or 2. So that's what you missed. So as for how to create someone with a person type that is not 0, 1, or 2, I'm zooming in on this use of the offset OX200 because I reckon that probably relates to the storing or the setting or the getting of the person type, maybe? Okay, so this looks promising because over here we can see that we're moving a value from rax plus OX200, which we believe is relating to person types, into EAX. Then we're comparing EAX against 1. If the 0 flag is set, if EAX was 1, we go down here and do this. Otherwise we cascade down to here, we compare EAX to 2, we jump if 0 down here, otherwise we cascade down to here, we test EAX, we JZ, jump if 0, down to here, otherwise we fall through here. So this here looks like it's a cascading set of blocks which deal with 0, 1, or 2, which resonates with us because we know that person types are 0, 1, or 2. So that's interesting. We can see that there's a else case, or not an else case, it just kind of falls through these blocks. I'm guessing that these blocks here are responsible for getting the attributes that are particular to different people. For example, we know that managers have a name and how much of an asshole they are, engineers have a name and how humorous they are, and hackers have the name, the humor, and the handle. So I reckon these 3 blocks here basically go and get data relating to the particularities of the people. And it looks like if we've got a person who is not any of those 3 types, then there's just a jump down here. We probably malloc OX320 bytes on the heap, probably to create room on the heap for the data about the person. We then memcopy and then we wrap things up. So okay, so here it looks like if we're going to allocate and create a person who is not of type 0, 1, or 2, then we may not even have a name. Or maybe because we all have names, maybe name is handled up here. Yeah, there's a mem copy of OX200. OX200, is that 512? Yeah, it is. So there's a mem copy of OX200 bytes. So this is probably copying the name. So we probably need to have a name for our naughty person who's going to break everything. But I'm guessing because we're not going to go through any of these 3 blocks, we don't need humorous, we don't need asshole, and we don't need handle. We just fall through to the bottom here. That's what I'm going to work with. If we see crashes, if we see bad crashes, or if we see no crashes, then that might be one thing to come back and revisit, whether we need to give more or less attributes as a pwn person. I did see up the top here that there was another reference to OX200. We can see here that we move something at an offset of OX200 into EAX, we compare EAX to 2, then we jump if less than or equal to here. Because remember, we've got people types of 0, 1, and 2. So less than or equal to goes here. Then it does the malloc and stuff. Otherwise, if we were to take this red leg, and if we failed this test here, then we end up returning with EAX equal to 0, which indicates, I'm guessing, an error. So we've got a conundrum. We need to create a person with a type other than 0, 1, or 2, but we do have this check here, a compare EAX2, followed by a JLE down the bottom here. And I am going through this. I do remember where the bug is. I do remember roughly how to do it. I don't remember how to do the exploit, but I remember how to trigger the vulnerable condition. I could have played dumb all night, but I kind of want to get to bed eventually. This had me stumped for a little while. By a little while, not anyway. Once I had the uninitialized variable, I was done pretty quickly. But this did have me stumped for a little bit. I was probably even going so far as to build my exploit, run it with a type of 4 or something, and it would just not crash. I was going, well, I'm not even creating the person I want. And it was due to this check here, where you compare EAX to 2, you JLE, and if you fail, you take the red path down to return 0. So we need to find a way to have a person type other than 0, 1, or 2 that still passes this check. To the doco, how does compare and then JLE work? x86 compare. That's right, x8 compare did like a sign subtraction and then set the flags. So compare does a sign subtraction of arg2 from arg1, the results of which are discarded. Blah blah blah. Blah 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 blah. And it sets these flags here. Good to have you around, Chris. Chris, I'll catch you soon, eh? Alrighty. So that's what our compare does. We'll keep this tab open because it may be useful to refer back to it. How does JLE work? In fact, x86 control flow. It's probably on this page. JLE. Alright. Loads EIP with a specified address if the first operand of the previous compare instruction is lesser than or equal to the second. See the JL for a more detailed description of the criteria. So here's JL. Blah 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 blah. Blah blah blah. Okay, so here we've got jump if lesser unsigned comparison. JB is the same as JL, so we're talking about a JLE, so it's from the JL family. So JB performs an unsigned comparison, whereas JL performs a signed comparison. So JL will respect sign. So dude. You should be a bigger part of my life, Mongo. Generic options and enable auto comments. Hot damn. What am I doing? Generic. I'm too excited to read. Generic options, auto comments. Where is generic auto? Where is generic options general? Auto comments. Yeah, cool. So yeah, I knew compare was CMP was compared to operands. I knew JLE was jump if less than or equal to. I wanted to get into the nitty gritty of signed and unsigned. If there's another thing I should be turning on, then that's I'll do that. But that's wicked. Yeah, that's cool. Big fan. Thanks, Mongo. I've actually got the IDA book. I should read the IDA book. I should learn how to use my tools. Thanks, Mongo. So we saw that JL is a signed comparison. Compared as a signed subtraction. So what if we've got a person type of -1? So we've got a person type of like 3 or 4. I think we're going to fail this gauntlet. We're going to slip down the red slip and slide to the bottom. But if we've got a negative person number, should do it for us, shouldn't it? Let's go with that theory. So we're going to touch up our function of make pwn. I think we're going to have a name. I don't think we're going to have humor. So let's get rid of humor. We're still going to justify the name to be 512 bytes long, but for this person who we're going to call, you know what, I'm not going to call the person pwn because that will potentially collide with the pwn lib. Let's call make pwner. Yeah, we've got manager, engineer, and pwner, and hacker. Pwner. You know, I should just be an adult and I say that and stuff it up. Pwner. Boom, there we go, using Vim like an adult. So pwner is going to be pwn.pack32. Let's go, what, -1? And then we're going to give it a name. Cool. So let's go pwner equals make pwner. Don't you love, but I'm sure I'm making so many actual programmers cringe at my variable name collisions. So the pwner is make pwner. A hacker. We only need a name, one parameter. So the pwner is make pwner a hacker. Let's go and replace Larry. We need a hacker. We need Mubix, and I want OJ because OJ is a good guy. Let's go and create pwner at the head of the list. And if we run this exploit, are we going to have this person who is of type -1 give us our crash? Because when we create a person of type -1, let's recap. Person of type -1. Hopefully we don't go down this red path. Hopefully it goes down this path here and actually creates them with none of these silly extended attributes like handle or humor or arsehole. Hopefully this person with type -1 will actually be created, and at offset 3200 OX200, hopefully it will actually end up saving the person with the type of -1, because then when it comes to display all, I see that dude, I'll be there in a sec. When it comes to display all, we're going to print our left square bracket, blah 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 blah. We're going to dodge these cascading if conditions and then set the setting of the function pointer, and hopefully we'll end up down here with an uninitialized pointer, an uninitialized variable being put into racks, and then a call to racks, and hopefully we'll see a crash on just some leftover stack garbage. Hopefully the stack doesn't point to somewhere executable that will hide the bug. Hopefully we'll actually get that crash. That's the theory, and hopefully that makes sense. If it doesn't make sense, OJ and Mongo, I'm sure, would be more than happy to help you understand. Cross our fingers, run the exploit, and see what happens. Hey! No, it's probably just shitty Python again. What happened? Integer out of range for capital I format code. So we can't actually pack Python. I love that I'm getting crashes, by the way, just because of my shitty Python that's feeding probably garbage to the process. That's too funny. Pwn.p32. Like, the ultimate fuzzing is just get me to try and write an exploit and just watch the crashes spew out of the debugger as my exploit itself, like Python, fails. Nope. So we can't pack a -1. What we can do is we can pack an OXFFFFFFFF, which is just FFFFFFF, because it's a 32-bit value, and -1, when you do 2's complement and actually represent it as a signed integer, will be a whole bunch of F's. So let's just go and do that. Let's be lazy. Make a comment that it's -1. See if we get the crash we wanted, not the crash we deserve. Hey! Crash. Invalid PC address. So we've got the null pointer being executed. That's good. Because you know what? We are in the habit of actually putting a lot of hex zeros on the stack. So that gives me confidence that we're on the right track. I've got a feeling that when we were probably making someone, there was probably all these trailing nulls that got left on the stack as a bunch of turds, which then got used as a uninitialized variable and then got called. In fact, we could probably be adults and actually like set breakpoints and stuff and watch this happen. Let's set a breakpoint on that call. Where am I even? Display all. Right, yeah, I'm in there. Call. So if we just go and GDB it. Yeah, so at that address there is our call racks. So let's go and db command.append break. We need to work like the star 0x. Already had a 0x there. I think it's star. I don't know why. Whenever you're doing stuff and stuff doesn't work, just stick stars in front of your pointers. And it'll work. So we've got a breakpoint set on that call racks. Let's run that again. So our breakpoint got hit. We're about to call racks, so we are reaching that part of the code. And at that point in the execution of the code, racks is actually set to 0. So that wasn't a just coincidental crash. That crash was actually caused by our use of a uninitialized variable. So cool. Furthermore, we can see that it was trying to call the printer function, the person printer function, for the person named a hacker. So that further kind of gives me hope that we're on the right track, because the pwner was named a hacker. OJ's trying to teach me stuff. In Vim, do control N to get autocomplete based on the contents of the current buffer, like the current yank buffer? Hacker. What am I doing? Control N? Control N's doing like nothing. Don't need to be in like insert mode, insert, control. Ah! That could have been really dangerous probably if I wasn't actually in a Docker container and was in Vim that I use day to day. I don't want like my day-to-day Vimming showing up in some autocomplete nonsense. Okay, so hang on, what am I doing? For example, if I was doing like actions, I could go Looks like it's actually pulling stuff out of stuff open in other buffers as well. So OJ, do you recall what I was doing when you were saying I should use that? Like what was the context for that? We only need one payload here. What was the context for that suggestion? Where do you think I should have been using that? Because I am curious. Alrighty, so we've got this breakpoint, and if we were to step into this, then we'd get a call racks. Racks is set to 0, and the guest arguments for this call is for a hacker to be printed. So that's neat. Like, we can actually... I don't think I realized this last time, but this actually gives you basically the entire call primitive already set up. Like, if you knew where system was, then you can just make a hacker named, or a pwner named shell, bin shell, and then it would actually call system. Yeah, neat. Because I don't think I used that technique last time. Huh. That, yeah, interesting. He's gone, is he? Alright. Catch him when he gets back. Alrighty, so we've triggered the bug. What are we going to do with this, considering we've got NX on and ASLR off? The other thing that had me quite curious is OJ's blog post. If I can go and pinch that link. Here it is. OJ's blog post did actually say... I think it was the README. ASLR is not enabled, which made me think that maybe OJ was saying that because I never actually pwned this in the context of a CTF. I wasn't at B-Sides, which is why I tested it. Excuse me, for B-Sides, and I was at Kiwi, and OJ and I were disqualified from actually, because we played the CTF. Our team actually won the CTF, and we did that while disqualified from playing this challenge. So I'm not sure if OJ meant for the challenge operators to actually have the server set up with ASLR totally off, so that way if you knew what distro the target was running and what patch level it was, you probably could have fished out, you probably could have, maybe if there's an info leak bug in the binary, then you probably could have deduced what the remote libc version was, then you could have got a copy of libc, then you could have actually looked at where system was. Mind you, because it's 64-bit libc already gives you like insta-shell gadgets anyway. So I was curious as to, is OJ around? No, he's not. Interesting, Mongo. So that is possible, hey? Huh. I think last time I may have just ropped it. Maybe. So we've got options. We could find system, and then just use this free call primitive. Like, it even lets you give as a single argument. Let's give it. I'm just trying to figure out if you got more than one argument up your sleeve. Anyway, let's give at least one argument. That argument is already a pointer that points to something. My mouse just died. Luckily, I've got a battery I prepared earlier. Yeah, it gives you a total call primitive just off the bat. So if you could find system, you could just go and do a print for a pwner person named bin2json, and you could win. So the question would be, how do we find system? What is in the import address table? Is it still called an import address table in Linux? I don't know what it is in Windows. Is it, if it's a static binary? Hang on. Is this a static binary? Like, is system already given to us for free, non-ASLR'd? Because if so, like, we're done in... I was going to say we're done in 10 minutes, but I don't want to say that in case I end up being dumb and here for 2 or 3 hours. So don't hold me to 10 minutes. Yeah, it's statically linked. So it's already got all of libc baked into it, so we should already have... It's not what I wanted. Does it have system? Or when you statically compile stuff, do you only get the functions you need? In that case, like the whole, discover the remote libc, if libc is ASL, blah, 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 that doesn't matter anyway, because this is statically linked. So there's, if you look at it in LDD, it doesn't even load libc. So what we're stuck with is what's in the binary. So thankfully, because it's static, like, we get a shit ton of code to go and fish for gadgets in. But is there system or exec or function for execute stack op? So we could just go and make like shit executable, maybe. What do we actually have in here? Do we have the string bin shell? I'm just curious, because if we do, then we may have the insta-win gadgets. No, I don't think we've got the insta-win gadgets. What have I missed? I did see a doot. Ah, okay. Cheers, Mongo. Yeah, cool. You almost totally sent me up the garden path for like 2 hours going through this binary going, it's gotta be in here, Mongo did it. Yeah, cheers. Yeah, thanks, Immerse. To be WM, hey. How's it going, Festec? Yeah, I've got a horrible habit of just, well, especially, I mean, normally I use, normally I've got my shit side by side, but I'm actually running a massive monitor at a dumb resolution, so that I can stream at a native resolution on my amazing Australian 1 megabit per second cable internet connection. Like, shit's crazy good. So I've got like very limited real estate to actually work on. Also, normally I do have IDA off to the side in a split, but as I was saying earlier, I've brushed up against the most awesome of i3 and VirtualBox interaction bugs, in which if I resize VirtualBox or move it around at all, it graphically glitches to hell. To fix it, I have to reload my i3 config. If I reload my i3 config, OBS goes to hell, which I'm using to stream, so I'm stuck not being able to resize IDA, hence why I'm just like, fuck it all, let's just go totally stacked. At Wolf's off. Okay, at Wolf, catch you soon, eh? OJ kept you up late last night, you were late for work. Awesome. Yeah, I agree. I'm not a Unix porner. Yeah, I agree. Some of them, like, admittedly, if you go to Unix porn and sort by top all time, like the first page, yeah, there's a bit of repetition, but there's some nice stuff. As for like the weekly drivel, yeah, everyone's stuff looks the same. I just love i3 not because it looks good, but because it's functional. And you're saying you use 2BWM. Hey, I'm gonna pop that in my personal browser. I will look into that later, because I am always down for tweaking my setup in the quest for efficiency and procrastination. So thank you. Alrighty, so what are we going to, we've got this whole call primitive. Like, are there any functions in here that could be useful if we called them? What's in here that could be? I'm just going to take a quick breather because talking is exhausting. I'm sure listening to me is more exhausting. So I'm going to take a quick breather, have a vape, and just scroll through this list and see if anything jumps out at me. If you want to go grab a glass of water, or another glass of whiskey, or another beer, or hit the dunny, now is probably a good time, because I'll just be here scrolling, looking dumb. I'll catch you in a minute. These are looking very uninspiring to me so far. I'm sure people have seen at least 4 things I should have seen by now, but I'm seeing nothing. Is there an execute file system call you can make .shell? Dovion, what is it you're referring to with execute file system call? Are you talking about ropping to somewhere that does a syscall based execv type thing, which I think is the path I'm going to have to go down. Right now I'm just looking for a quick win, like some sort of system-like function. Not that I have my hopes up, I'm just enjoying the break from speaking. What do these dlsim functions do for me? Obtain address. I was thinking I could load a library and maybe abuse that somehow. DL open. Like, I'm looking for something that I could abuse by just basically calling it with bin shell and having it go. I don't know how to open that as a library, I'm going to run it. Like, something like that would be glorious. If that exists. If that does exist, please let me know. For the exploit, yeah, are you talking about Dovion? Are you talking about ropping a syscall based execute call? Because yeah, I'm about to basically just chuck the thing at Ropper and friends until some chain falls out. I'm just going to go out on a huge limb here and look dumb on stream. Can you like execute a library? Like if you try and load it in a certain way, will it execute something? Alright, so for a magic library, you can basically be some sort of polyglot executable / library. Boring. Yeah, no, that doesn't look interesting at all. I think we're stuck with ropping. Yeah, there's a execute syscall on Linux. Not too sure about pthread, but yeah, there's tools that'll basically just punch stuff out for you. Do I have my tools? If you've just tuned in recently, I've been discussing the fact that I lost a disk yesterday, so my machine is in various states of not being set up yet. I think RopGadget 403 is my normal poison. I think 403 is from before they went and turned it into Python, like it used to be a C program, which I just found worked quite nicely. Let's go and run this and just see what happens. So Richo submitted a patch for this a day ago. What? I saw him post a write-up. I had a quick flick through the write-up today. I didn't want to kind of spoil too much for myself. What's the bet that he kind of brushed up against a bug while solving this problem, while solving this challenge, and he's gone and submitted a patch in response to that? I reckon that's totally what's happened. OJ's binaries, bringing the open source hackers together to improve the state of the tools. Love it. Yeah. Yeah, so RopGadget 5 was like a Python rewrite, and I probably should go back and try and use it again. But I found that when I tried using it last time, I was just having issues. Like, it's probably gotten better. Obviously, it looks like Richo had some success with it, but 403 is near and dear to my heart. So let's just go and build 403. What have we got? Make warnings for days. And we've got RopGadget. Alrighty. So what have we got? RopGadget, give it a path to the binary. To which... Actually, you know what? We should probably actually figure out how to rop first before we go and punch out chains. That'd be a good idea, wouldn't it? We should probably actually get rip control and get to the stage where we're actually able to kick off a chain before we go and start being too excited about punching out chains. I reckon that's the way we're going to go. That's the way I'm going to go at least. I'm going to see if I can rop to a syscall execute bin shell. Alright, let's get rid of Mubix Larry and OJ and strip it back to just the Pona. And we'll need to create a hacker. We don't need Mubix, we don't need OJ. But we will do actions plus equals pwn dot. Actually, you know what? We'll create the Pona first, and then we'll create a hacker. Because the good thing about a hacker is he's also got a handle. And if we need that space for a bigger ROP chain, it may kind of give us more stack control. Maybe that's a bad idea because handles are only 256 characters long. And it's going to cause a different stack frame layout. Let's create a... Well, we need to create a hacker, so we will do Mubix still. Mubix will just be our token hacker. And we'll just create everyone at the head. Until that proves to be a problem, we'll just keep on... We'll create people at the tail, keep them in order. Until that proves to be a problem, we'll do the tail. So we'll create Mubix, who is our token hacker. Pwn.p8 create. And then we'll create a, at the tail... you know what? Let's go and lift this down. We don't need that anymore. We don't need Larry anymore. We don't need OJ anymore. Pona will go and carry this down here. So we're going to make a... Let's create a manager. A times 256, because the length of the name can be 250's name is 512. So I'll create a manager with a name of 512 A's, so it won't get null padded at all. And a manager has an asshole value. Make it BBBB. So we'll create a hacker at the tail, token hacker. We'll create a manager at the tail, and this manager is actually going to cause a stack frame to be thrown with a whole bunch of A's and B's on the stack, so that when we see the crash, if we see A's and B's in it, then we'll go, okay, this uninitialized variable probably has its content set from the previous execution of the creation of a manager function, and that manager had a name full of A's and an arsehole quotient full of B's. Then we'll create our hacker, and then we'll print them all to trigger the bug. We'll send that up. Okay, so let's see what this crash looks like. So we've got a call to racks. Oh, because you know what? We're actually printing Rob Fuller. Let's get rid of this breakpoint. We've proven our point as to how the bug works. No crash. What happened there? Like, it didn't even actually print anything out about our Pona at all. What did I screw up? So actions are going to be create Rob Fuller, that's a tail, who's there. Create the manager, that's a tail, who's there. Create at the tail a Pona named a hacker. Didn't appear. What if we put hacker at the head so he's the first one to get printed? So, that's not the crash I was expecting. I was expecting a crash on a whole bunch of A's. In this case, we've got a crash at the character lowercase r, which might be the lowercase r in the hacker's name, question mark. Let's get rid of the manager and see if that still happens, just to kind of keep shop tidy. Yep, crash on the R. Okay, so what if we go and make, instead of a hacker, let's go and make a hacker's name a times 512. Because maybe it's actually the yeah, that makes sense. If we had kept a hacker there, but we'd kind of created the manager after the hacker so that the manager's name was fresh on the stack, we probably would have seen what we wanted to see. I'm just curious, is this going to give me what I wanted? Just because we have to kind of make sure that the most previous function call to have occurred before the printing was the making of the manager with, yeah, the name of all A's. Segfault on. Yeah, there we go. We're calling racks, and racks is a bunch of A's. That's what I wanted to see. But to keep things simple, looks like what we can do is not have the manager. So comment that out. Instead have the hacker be A times 512. Actually, let's make it B, just to get a different crash to what we just got. Yeah, there we go. Okay, so we can actually cause the crash just with a hack. We have to create a token hacker, and then we create our Pona person, and the Pona person has a name full of B's, so the stack frame that gets thrown as the creation of that Pona person has a name which leaves turds on the stack, which then happens to kind of, some of them slot in to the my brain just paged a whole bunch of stuff to disk. The Pona's name ends up slotting in to the spot where the uninitialized variable ends up being, which then becomes a function pointer which gets called, and we can control rip, even though it's not showing up as rip here. Rip is pointing to a call racks, and racks is full of B's, so we've got rip control. Yeah, thanks Mongo. That yeah, cheers. I think you had that before I had it. So thanks. Yeah, asshole full of B's has got a sting indeed. That's managers for you. Hopefully my boss isn't watching. If you are, I don't think you're an asshole full of bees. Alrighty, so we've got a crash, we've got rip control. What are we going to do with it? Let's run that again, let's see what the crash looks like. Oh, this looks good. At the time of the crash, the stack actually points to something we don't control. Then a pointer to something we do control, but we don't control the pointer itself. And then we've got our bees. So if we were to find a pop ret, and we were to go and put into the first of all, we need to make sure we tighten up our rip control, which I'll do in a second. But it's looking really good for ROP, because the stack actually contains a whole bunch of stuff that we do control. So that we've got a good spot to put our ROP chain in. We don't have to worry about pivoting the stack too far to actually have RSP point to our chain, and away she goes. So let's focus on actually tightening up our rip control. Instead of b times 512, let's go and do pwn.cyclic 512, and just go and punch out a cyclic pattern. If you haven't seen pwn.cyclic before, what it does is gives you a string that never repeats. It's the exact same thing, just a different brand to Metasploit's pattern create. And it's built into Pwn tools, so you've kind of got it for free. You don't have to go and run Metasploit, copy, paste it into your exploit. It's there she is. So we'll use that to, instead of a whole bunch of bees, have the pwner's name be a cyclic pattern of length 512. And here's our crash. We can see here that we've got in racks, we've got C, AAA, D, AAA. So now what I'm going to do is I'm going to break out the pwner's name. So we're going to have enough A's to kind of pad out the name up until the pointer, which gets eventually used as a function pointer. So we'll do A times pwn.cyclic find. We need to go and get racks. So just grab. Actually, you know what? Let's do that again, because I'm not used to doing 64-bit binaries. What we should have done. Let's comment this out. We'll come back to that in a second. I should have done n equals 8. So we want to make sure that at least every 8 characters is unique. Otherwise, we can end up with collisions inside the pattern and sadness. N equals 8. Dang it. Try again. Hang on. I'm being stupid. Just for something different. That n equals 8 needs to go inside the call to pwn.cyclic. By the way, Mongo, there is a 15-second delay between my stream and chat, so I very much expect to get you pointing this out in 5, 4, 3, 2. Alright. Mongo didn't feel like calling me out on that one. Let's try this. That's looking better. So now we need to do the pwner's name equals A times pwn.cyclic find. Let's go and pinch that value that's in racks. Here it is. And we need to again specify that n equals 8, because the pattern was generated under the condition of n equals 8, so that at least every 8 sequential characters would be guaranteed to be unique within the whole pattern. You know what? Is this like the beginning of the string? Or at least very near to it? I bet it is. I bet that was mostly unnecessary. Pwner name plus equals B times 8. Pwner name plus equals C times name size minus the length of pwner name. So this here is trailing garbage. This here is function pointer question mark. This here is of course the padding, the leading garbage. And then we need to go and swap this here out for make the pwner with the pwner name, and run this, and hopefully we've got tight rip control. So call to racks, and racks is full of bees. So at the time that we have BBBB being called, what does the stack look like? Oh no, we did have some A's after all. So the stack looks like this: pointer, pointer, then some A's. And we've got 8 A's there. 1, 2, 3, 4, 5, 6, 7, 8. So that's enough for a pointer, a 64-bit pointer. So what I'm thinking of doing is having the function pointer be a pointer to pop, either pop ret. Now what's got A, B, C. Alright, so we've actually got A's, B's, then more A's, then more B's. I wasn't using A's and B's anywhere else, was I? Nope. Huh. So okay, looks like we've got some stuff on the stack being doubled up. Ultimately what we want to do now is find a way to pivot the stack just a little bit so that the stack points to something like a whole bunch of C's, something that we're not going to have to worry about our pointers, or sorry, our function pointer being in the middle of, so that way we can then logically conclude that that's where our ROP chain is going to go, and we can ROP to freedom, as long as we don't use any more than, looks like 200 bytes worth of ROP chain. So I'm guessing there's no bad characters in here, because everything we've been doing so far, the protocol is based on, kind of a length value protocol, so I'm guessing there's no bad characters, but I guess we'll find out if there's weird stuff going on. That's one of the first questions we should ask of ourselves if we've stumbled upon a bad character. Otherwise, we need to pivot the stack. We should probably just go ahead and run ROP now, or ROP gadget. ROP gadget, now that we've kind of got an idea of where we're going. Twitch, bin2json. We just run it, then we get, we actually get like chains and some gadgets. Neat. So it looks like it's actually created an entire chain for us. I'm just going to quickly go through this in my head, take a quick break and make sure it looks logical. Yep, this chain looks totally reasonable. As long as ROP gadget's not lying to us about what each of these gadgets are. What we're doing is we're popping a pointer into the .data section, which is just a random writable section where we can just go and take a big dump on. So we're popping a pointer to a writable area of memory into RDX. We're popping the string /bin//shell. The reason why there's an extra slash in there is to keep this to an even multiple of 8 into racks. We're moving what's in racks to what is at RDX, so we're writing bin shell into .data. We're then popping into RDX this address of .data plus 8, so kind of the next keyword inside the data segment, into RDX. We're then zeroing out racks. We're then moving that null pointer to what is at RDX, so we're basically null terminating this string within memory, I think. Strings and little endianness and stuff. Let's go with that. Let's go with... Maybe it's not null terminating. Is it going to null... Is that null terminating the string bin shell? Yeah, because, sorry, strings aren't written in little endian, are they? No. Integers and pointers are. Okay, so yeah, this has two effects. First of all, writing the value 0 to .data plus 8 will null terminate this string. It'll also give us a null pointer at a known address in memory, which we need to achieve execve. If we quickly look at the man page for execve, we'll see that it takes 3 arguments. First argument is a file name that we want to execve. This is a system call based execution primitive, which of course we're going to set to be the pointer to bin shell, which will be null terminated. We then take a char star. So we take a char star for argv, which we're going to is going to be a pointer to bin shell, which then has a null terminated. Do we need that to be like a pointer to bin shell? Probably. And then env which we're going to just YOLO to be 0. So we're doing that null termination. Yeah. And then we're going to pop the address of .data into RDI. Going to pop the address of .data plus 8 into RSI. I'm going to pop the address of .data plus 8 into RDX. Okay, so we're just going to YOLO 0 out argv as well. We're not going to have a real argv. We're not going to have a real env. We're going to cross our fingers that abusing execv like that will work. As long as bin shell doesn't expect to have a sensible argv, that should work. And that chain will then pop the syscall for execve into racks, which is how Linux kind of tells the kernel when you trigger a syscall, which syscall we're triggering, and then there's a pointer to a gadget which just does a syscall. So this chain here, if we can get this chain to kick off, we should get a shell. And because this sort of pwnable is designed to be published in a way in which you interact with stood in and stood out over the network, then popping a shell is just going to give us that shell back straight over the network. No need for a reverse shell, no need for a bind shell, just spit the shell back over the existing data channel we have open. So I had one more thought on that. Oh yeah, and of course the reason why we're doing ROP here is because we cannot simply go and stick some shellcode in memory and then use our RIP control to go and just send execution off to that area of memory, because if we were to write shellcode to memory, it's probably going to be on the stack or on the heap, which will be non-executable, given the fact that this is a NX binary. That's why we're doing ROP. We're doing ROP to beat NX. It's a good thing ASLR's off, because otherwise we'd have to have some sort of info leak to basically establish a pointer somewhere into the binary, and then we'd have to build our ROP chain with that offset in mind, which wouldn't be impossible as long as we could find an info leak, or as long as we could brute force ASLR, but it is very nice of OJ to not make us do that. I'm sure Mongo has a ASLR defeating exploit already. So we need to... Man, this is a quiet song. Or is it just me? Where's my music at? That's better. Yeah, so we need to do that stack pivot and stuff still. Let's go and pinch our ROP chain first. I'm sure there's many people looking at me using Vim going, don't do that. We don't need to print anything. So we've got our ROP chain ready to rock and roll. We just need to find a way to pivot the stack off to an area in which a ROP chain will pop. And then we put our ROP chain there. This looks like a pretty... I mean, let's println ROP chain sys.exit1 import sys. How big is this ROP chain? Pack is not defined. You know what? Screw you and your pack. Oh, that would have been bad. Let's go and use Pwn tools. Okay, so our chain is 144 bytes long. We did see that, you know, C repeats 192 times, C repeats 200 times. Names are 512 bytes long. We should have room for this chain, even if it takes a couple of gadgets to do the pivoting and whatnot. Alrighty, stack pivot. So now when I say we need to do a stack pivot, if you look at the state of the crash binary, we've obviously got rip control. Rip was, I think, a bunch of B's. Yeah, rip's a bunch. Yeah, well, Rax is a bunch of B's. We're about to call it. So when we do a call is going to push a save return pointer to the stack. So this is what the stack currently looks like. This is the top of the stack. This call is going to push another pointer up above this one. And then if we were to have Rax point directly to, say, a return, then it would return to the next pointer on the stack, and it would return to where the function was actually supposed to return, and we wouldn't probably even see the crash. If we were to point Rax at a pop return, where it just kind of pops into any old register return, then what it would do is it would pop the save return pointer into some register, and then it would return to this pointer here, and it would execute OX204 as code, which sounds like bad times. If we were to find like a pop ret, then what it would do is it would pop the save return pointer that the call is going to throw into a register, pop this into a register, and then it would return to this address here and execute AAAA, BBBB, a whole bunch of C's as code. And this to me looks like a heap address. You know, these are stack addresses. This is probably an address out in the heap. That allocation is probably not executable. Does anyone know how we check in GDB? Let's do VM map, is it? Okay, so I mean, VM map's telling me that bin2json itself is mapped twice, once as RXP, once as RWP. I don't even know what the P is. And then we've got something that's mapped. Then we've got the heap, and the heap is readable, writable. Stack, which is these addresses here, is readable, writable. VDSO is readable. So we can see that the heap is probably not executable. Is there a cheats way of basically saying, hey, the page within which this pointer lives is what are the permissions on it? Does anyone know how to do that in GDB to interrogate memory permissions? Probably going to be bad times. If we return to the heap, it's probably going to be bad times. So I've lost track of where we are, but if we do like a pop for the save return pointer, pop ret, then it will return to the address a whole bunch of A's, which is sounding pretty good because we can change those A's to be appointed to some other drop gadget, right? We could make the A's, which we know is just leading padding, be a pointer to a pop ret, and then we'd return to a whole bunch of C's, and here we could put the ROP chain, away we go. Alternatively, if we were to just find I've lost track of where I am, pop ret, if we could even just make that be a straight up ret, then we know that the B's are already going to be appointed to with pop ret, and then that would land us inside our C's also. We probably just need to have some padding in there to account for the fact that we're not actually going to be hitting the top of the chain, potentially, if I'm counting my pops properly. Point is, we can just find like a couple of pop rets and pop rets and basically eke our way down the stack a bit to a place where we control a whole bunch of stuff that we don't have to have B pointers to anything in particular, and whack our chain there, and away we go. Yeah, thanks Mongo. I should look into that. I should know how to check page permissions. So yeah, we just need to find some pop ret kind of stuff, and we should be able to work our way down the stack with a couple of innocuous ROP gadgets, which basically just move the stack down a bit to a spot where we're ready to have our chain kick off. So what do we need? First we need to do pop ret. We need a pop ret. So we get some stuff here. Not many. There's surely more gadgets than that. I'm guessing ROP gadget just did enough interrogation to find a ROP chain for us. What does the help for ROP gadget say? We can do dash only pop. Yeah, let's do that. Oh, hey, here we go. Here's our pop ret. That's what we wanted, yeah? 3 pops and a ret. Pop for the safe return pointer. Pop ret. Let's do that. Pop ret. So let's go and pinch this here. We don't need the length, we don't need sys, we don't need sys. Pop ret equals that. Where was my pona name? All the way up there. We can just go and pinch that, drag it down here. So now we know that there was only 8 A's there, yeah. Yeah. Maybe. I think so. Hang on, I'm just gonna do a quick sanity check here. If we go A times 8, B times 8, do we still end up winning? Yeah, okay. Rax has got B's, so we should be fine. So what we can do, instead of these 8 A's, we can do our pop ret. And what's that going to do? It's going to go pop the safe return pointer, pop. And then it's going to return to what was A, but now it's a pop ret, and we should see a pop ret perfectly. Like it's like we get to use the same trampoline for 2 little pivots. So that should. Let's go put pona name plus equals C times 8, and let's make a whole bunch of D's. And we should basically at this stage see, get it? See, we should have a we should get rip control. Rip should be a whole bunch of ASCII C, and then the stack should point to a whole bunch of D's. And that means that we've succeeded in our stack pivot, and then at that stage we basically just swap out the D's for our ROP chain, and we should have shells. And I've like broken. Yeah, pwn.p64 helps to actually pack your pointers. Rip. Nope. Rax is still a bunch of B's. The hell did I? Hang. So I swapped out the A's. I swapped out the padding for my pivot gadget. Didn't swap out the B's. Nice. Well, I mean, it's going to work out anyway, because we did want pop ret in the A in that slot where the A's were. We just also want it where the B's are. So this should just hopefully just work. This is the function pointer. This is padding. Keep on pivoting. And I'm hoping that the C's end up in rip, and then the D's end up at the top of the stack. see how we go. Okay, so we don't have rip control per se, but what we've got is rip points to a ret, and at the top of the stack is a whole bunch of C's, followed by a whole bunch of D's. So this has actually achieved what we wanted. It just, I thought the GDB would have actually shown that rip was OX CC. It's not. It's showing us that rip points to a ret, and then at the top of the stack, the pointer that this ret is going to return to is our C's. So at this stage, we should theoretically just be able to drop our ROP chain in instead of the C's, and we should just get a shell, question mark. We'll leave all these D's there as trailing garbage. We actually don't need them because things will get padded out with nulls for us. Opponent name plus equals the ROP chain. And so we're going to have GDB attached, and GDB should show us that a sub-process is being executed. And then the good thing is at the bottom here, as is habit for me, I've already got the t.interactive, which is what it's going to do is the shell should execute, and then we will just call the interactive function on the tube that we're sending all our exploit down, and that will have Python's pwn tools just kind of give us this red $, which should hopefully be a working shell. Run the exploit and cross our fingers. Hey! Process is executing a new program, user bin dash. And there we go. We have shells. So that is bin2json, and we're all done. We've defeated NX using a ROP chain. We did just a little bit of pivoting around the top of the stack to kind of just skip over some garbage. But most importantly, I think it was kind of cool. We went through, we discussed how we identified and discussed a uninitialized variable bug, which was then being called as a function pointer. And we then wrote an exploit, and away we went. So I think we should be pretty happy with that. Mongo, what did your exploit look like? Did you roll a ROP chain, or did you have other trickery? And for that matter, sorry, I've forgotten your name. Immerse, did you have a? I think you had an exploit, didn't you? Did we all end up going down the same path, or did we have different stuff? And I'm curious, if you used a ROP chain, did you build it yourself? Did you use a tool? So which tool? 'Cause I'm always on the lookout for new shiny. Did I hack Google yesterday? No, you must be thinking of a different stupid-looking red mohawked person. Okay, cool. Mongo, have you've actually published your exploit? Did I see? Is it up here somewhere? So I think Richo's. Okay, Mongo. So, Mongo, do you use ROPGadget 4 or 5? Because I really need to go back and check out 5. OJ's was custom. Nice work. Any questions, queries, or concerns from people before we wrap it up for the evening? Does the whole idea behind uninitialized variables make sense when they get used as function pointers? Obviously, that's straight to rip control. Okay, Mongo used version 5. I should check out version 5. Drepler, good to have you around. If you're keen to learn this sort of stuff, have you done any sort of memory corruption stuff before? Yeah, nice, Mongo. Yeah, I'm a holdout. I've had good times with ROPGadget 403 before the Python rewrite. I think I tried it pretty early on in their Python rewrite days. It was kind of janky. It's probably better now. But yeah, I think version 4's still got a place in my heart. Yeah, same sort of question from OJ. What level are you at now? The other question, Drepler, is do you want to do Windows stuff or Linux stuff, or do you not really care? Because if you don't really care, you're welcome, Parks. Thanks for sticking around, and thanks for the whiskey. That was a delicious drop. Yeah, OJ's plugging my material for me. I put together a Windows stack buffer overflow tutorial, slide deck, and pwnable for a conference earlier this year. If you're keen on Windows, that's a good place to start. Otherwise, if you're keen on Linux, a really good place to start is Protostar's exploit exercises. Protostar ISO. Search Google for Protostar exploit exercises. It's got a whole bunch of levels that walk you through from the very foundational ideas of a stack buffer overflow through to exploiting a stack buffer overflow. Same thing again for format strings, same thing again for heap corruption, then some network-based stuff, and then some putting it all together exercises. If you're brand new to exploitation, if you want to do Linux, Protostar's great. If you want to do Windows, you can check out the do stack buffer overflow good stuff that I smashed together in a real hurry for a conference. Or check out CallEncoder's stuff. CallEncoder has some really, really good tutorials. They're a little bit old, but they're still fantastic. Just search for CallEn tutorial part 1. The only issue with these tutorials is they can be a bit painful to find. I don't know if there's a good index for them on CallEn's. Oh, here we go. You can probably click the next button here a couple of times. But what I normally do is I normally do the tutorial, do part 1, go to Google, search for part 2, boom, there it is. Part 3, boom, there it is. CallEn has a lot of good stuff for Windows that goes well and truly beyond what do stack buffer overflow goes through. Do stack buffer overflow basically only just touches on part 1 and part 2, I think, of CallEn's stuff. So check that out. Finally, if you don't really care about architecture and operating system, I can't type micro corruption. I'm a huge fan of the micro corruption web-based binary CTF. So it is binary. It's presented as a website, but it is very much a binary series of challenges. It is not Intel. It's the MSP 430 microcontroller. And it's obviously not Windows or Linux. It's they're embedded devices, but you get this really quite nice web-based debugger, and you get quite a few challenges that walk you through from the very basics of reverse engineering and just kind of going through memory and understanding how program code works, how the assembly works, and then doing things like pulling the password straight out of RAM, right the whole way through to memory corruption exploits, return-oriented programming, heap exploits, and all sorts of really cool stuff. What I love about micro-corruption is, especially for people who are new to it, it doesn't get you in the habit of thinking that Intel i386, x86, x64, it gets you out of the mentality of that's all that exists. And it stops you from building Intel habits by default. It forces you to think, first of all, it's not a 32-bit, it's a 16-bit architecture. It is little endian, but it just kind of gets you out of the habit and gets you out of the trap of getting stuck in the Intel world. And it kind of opens your mind up early on and teaches you the foundational knowledge without necessarily giving you the Intel tunnel vision. So I'm a big fan of micro corruption if you want non-Intel, non-Windows, non-Linux binary exploitation. Where was I? I will, OJ. We'll definitely enjoy a couple of glasses together. Okay, Mongo. I have done W3 chals. I've done quite a few of them with a good friend of both yours and mine. I didn't know W3 chals worked all the way up to kernel. I might have to go back and give that another go. The Haxis team. Haxis? Oh, Haxis team. I'm looking at Steam. Steam? What? The Haxis driver was really interesting. I really enjoyed that. OJ, you and I need to go back and actually finish off the Haxis series of challenges. Yeah, I agree with OJ. It does help. If you want to be writing exploits, you at least need to know something like Ruby or Python. Stitching together exploits in a hex editor and then firing them off with netcat is not fun. You need to know Python in as much as being able to just basically smash strings together and calculate lengths and calculate the number of times you want to do something. Pack stuff as integers in either little or big endian. You need to be able to open up TCP sockets and send stuff. I'm lazy, so I use Pwn tools. Yeah, that's really kind of largely you need to know how to make functions just to kind of make your code look pretty. That's really the extent of how much of a scripting language you need if you want to write basic exploits. If you're going to write more advanced exploits, then you're going to need to know a lot more in order to write the more complicated exploits. For example, when you need to make sense of info leaks or you need to do other cool stuff, you will need to know a lot more scripting, but that'll kind of come with time. Like, I never really did bother with formal programming training. I kind of learnt on the job, as it were, for exploit development, and back in my sysadmin help desky kind of days, I learnt shell scripting and Python scripting back then. That's in terms of building, in my opinion, building the tool, the exploit. In terms of understanding the target, then the more programming experience you have, the better. But again, if you're really keen to jump into exploitation, I am new in programming, so yeah, if you're interested in programming, for sure, like it's a fantastic skill. But if you're learning programming just for exploitation, I'm sure you're not. But if you were, then I reckon you just learn on the job. Read the man pages, read the doco as you go, and you'll pick it up as you go. You'll also pick up terrible habits like me as you go. But that's, that'll shortcut the whole learning programming kind of step. Yeah, big +1, and plus 100 to that when not masters. But yeah, OJ and I love to teach. We love to chat about this. How often do you guys do these videos? I try to do them twice a week. So I do them Wednesday nights and Sunday nights Australian time. There you go. OJ's aiming for one a fortnight. Yeah, totally. Like, I agree with Mongo. For example, if you go and read the channel description I put down the bottom, there's a question in the FAQ that says, can you teach me how to hack? And the answer is probably not, because for a while I was getting in, and still do get a lot of people who turn up and say, can you teach me how to hack? And to that the answer is often no. If you come with specific questions and specific interests, or what should I look at, what should I learn, the questions like, is programming useful to know? Then it's like, that's the sort of question we love. If you ask, how do I hack, then the description says it all. I think that's asking for quick wins, easy wins, and not really wanting to learn. It sends the wrong message. If people are interested to learn, then I'll sit here and chew their ear off for as long as they'll put up with me and not close the stream for. It's about lunchtime here in Europe. That does work out well. OJ, do you know of any good YouTube channels? I mean, you can always go poke around stuff like, is Security Tube still a thing? I used to watch some stuff on Security Tube, and it's not great. It's good to kill a couple hours on, and I've got friends who have said really good things about things like their assembly course. So I mean, some of these just look like how to use the Kali tools. Actually, these look pretty good. Yeah. Security Tube's come a long way. I would, if you're keen on videos, I'd suggest you check out Security Tube. Avoid plural site. Yeah, the call end tutorials, if you're interested in exploitation, are really good. If you're brand new to programming, learn Python the hard way is really good. If you've programmed a little bit before, learn Python the hard way is still really good. Learn Ruby the hard way is pretty good too. If you need to use Ruby, I'm sorry. But you'll need it for stuff like Metasploit modules. I've actually warmed to Ruby a bit lately, but yeah, the learn X the hard way things just go learn Python the hard way. Zed Shaw can be a bit of a jerk, but it's really good material. It's free online. You can go and buy a book, but if you scroll hard enough, then you'll see that there's learn Python the hard way for free right here. I think there may be a downloadable PDF if you go looking hard enough. Looks like when you buy it, you get the PDF, but you can just read the HTML one for free and go through the exercises. So, yeah. Learn Python the hard way should walk you through a lot of cool stuff. Let's not turn it into a language war. Oh yeah, I forgot about Learn C the hard way. I was actually doing that a couple of months ago and abandoned it because I got bored. Had other stuff come up. So there you go, Learn C the hard way is another opportunity. Learning C is good because it lets you, if you want to build system tools and drivers and stuff, do that. If you want to break a lot of crappy software written in C, it also helps you do that. So learning C, learning the foundations of C is good for understanding your target in a lot of cases, and understanding a lot of CTF targets as well. Oh yeah, one more thing. If you want to watch the archives of my stuff, then moving forward, you should go check out my YouTube channel. I know the video quality, especially when text moves quickly, is horrible. It's because I get a whopping 1 megabit per second upload. So what I do is I actually spool it out to disk at a higher bit rate than what I stream it at, and then I leave that YouTube upload go on overnight. So it'll be higher quality if you check it out on YouTube instead. Also, if you want to do me a big favor, subscribe to my YouTube channel, because I want to get to 100 subscribers so that I can pick a vanity URL rather than having the stupid URL they've given me. I don't care if you watch my stuff, I just want a cool URL. Python's like shitting in your own mouth. Ruby's like someone else shitting in your mouth. Yes. Yes. No. If swearing's at least mostly on topic, if it's at all on topic, I won't care. If you turn up and just post ASCII boobs, you're gone. But yeah, nah, cussing's totally fucking fine. Parks, the sword giver giveth, and the sword giver taketh away. Mongo, thank you, means a lot. To be honest, I was a bit nervous seeing you in the room. Turned from let's build an exploit into let's not look too dumb in front of Mongo. So I'm glad you enjoyed it. Thanks for dropping by. I really appreciated your input, by the way. I really appreciated your teaching me how to use IDA. Hitting R to twiddle the bytes into ASCII was great. Turning on the general comments was also really good. If you ever catch me doing dumb stuff in IDA, I'd love it if you pulled me up. I'd love to learn the ins and outs and be able to demonstrate the ins and outs of IDA to the people watching. I really appreciated that, so thank you. Yes, I got one sub out of the night. That makes me happy. Good to have you around, everyone. I really appreciated you sticking with me on this one. I was really looking forward to the stream. I've been looking forward to it for a lot of the year. So to everyone who's turned up tonight and enjoyed it, thank you. I'm glad you're going to show up for the next one and go, this has gone to crap because Justin sucks at picking topics. I was just very fortunate to have OJ give me a brilliant binary to show off, and I really enjoyed this challenge. It was great because this was actually the first uninitialized variable bug I'd exploited, and I found it really quite refreshing after doing way too many stack buffer overflows of different flavors. And so I hope you enjoyed it. It's been fun. Thank you so much for dropping by. Thanks for your patience and sticking with me. Hope you learned something, and I hope to catch you on the next stream. At this rate, I think my this weekend is open. I've got a family gig on in the afternoon. If I can sneak away from that at a reasonable time, then we'll be streaming on Sunday night. Don't know what on. If you've got any suggestions of things you'd like to see, or things you'd like to hear about, or topics that we could just chat about and discuss. If you've got a binary pwnable that's annoying you, if you've got a web pwnable that's annoying you, I'd love to have a crack at it for you, and we can work on it as a team. We'll figure something out, hey? So thanks very much for dropping by. Take care, and I'll see you all on the tubes.